We're online, Josh.
Okay.
Well, I'm almost online, but then I'll introduce you.
All right.
just for you to know.
All right, cool. That's fine. So I'll just share my screen now.
Okay. Hi everyone. We're back to the it's time for the workshops, right? Essentially the workshops will be different projects and developers actually diving deep into the technology and then just showing you how to build using certain platforms and then giving you ideas on what you should build on. This video is actually pretty important. We will be putting all the recordings of all videos in the Discord channel, and the essence is for you to watch something in case you're missing something before you ask questions, right? We will definitely put all these videos again in the resources of the Discord channel. Thank you, Joshua. Joshua, our first workshop is from Joshua. Joshua is a software developer based here in Silicon Valley. However, he travels everywhere and he spends most time in the Midwest, where he launched another accelerator. Joshua will be talking about the Babylon DAO, which is coming from his work with WIASI Research Institute. So Joshua, over to you.
Okay, awesome. Thank you for having me. I'm Joshua Arma. I'm really focused on AI engineering and data science. My background has been primarily in software. I've been in blockchain for about 8 years now. And what we're going to talk about is a challenge that we're posing to the community to build a DAO for social impact. And basically, the Babylon DAO, Decentralized Autonomous Organization, is going to be a project to focus on helping communities with specific needs. And we're going to essentially curate a few different challenges. But to focus on the topic at hand, I'm going to start by just basically sharing the challenge, talking a little bit about, what a DAO is, and then how it relates to, a use case. So the challenge itself that we're going to be talking about in the Discord, you can see that there's it's called Babylon DAO nonprofit. So basically, the challenge is to build a DAO for a social impact purpose that exemplifies the future of the online communities, showcase why this matters to the users, and how it will drive value to online community with a specific set of needs that can be addressed through a DAO. So an example of this is right here. So a DAO is a decentralized autonomous organization. And essentially what that means is that the DAO itself has a set of rules and policies that is embedded in the code, and it actually is governed by smart contracts. And a way in which we can work with the DAO is by essentially creating a need. A need could be something as simple as voting on a specific project. Like for instance, we want to add a new feature to an app, and this app happens to be built on a blockchain. So typically, decentralized apps will have a community that, and the token holders can vote on certain features or certain things that they want to see happen in their community, and then they can utilize that for the voting purpose. Also, with blockchain communities, as you know, a lot of people that are token holders are able to be a part of the governance of a community. An example of this is MakerDAO. MakerDAO and Ethereum not too long ago had almost an emergency shutdown, but the community was able to come together and vote to provide liquidity for DAI, which is the stable coin in MakerDAO. So MakerDAO is a great example of an existing DAO project that is really about sovereignty with finance and being able to create sovereignty through a currency that is a stable coin that is backed by other crypto assets, primarily Ethereum. And with the DAO, when you are voting and taking initiative on something, you're using your crypto to vote in favor of whatever you want to have happen. And basically, an example use case for a DAO could be like crowdfunding. A lot of projects in the past, 8 to 10 years have used crowdfunding as a vehicle to raise funding. There's also popular platforms like Kickstarter, WeFunder, Republic, where you can go and find startups that are projects that are crowdfunding. But outside of that, there are also peer-to-peer projects, things such as food shortage in local communities, homelessness in disadvantaged communities, or even something as simple as educating the youth and making sure all students have a laptop as the COVID pandemic has taken over our society. And crowdfunding doesn't just represent investors; it represents also giving back to the community. So in this sense, we can look at a use case for the DAO as a crowdfunding vehicle that can essentially allocate resources. For instance, if there's a need in a certain community, such as giving laptops to kids that are in school and they don't have access to that, we can crowdfund, let's say 10 grand to buy laptops for certain kids that are in need of laptops. And as that evolves, these kids are able to learn from home. And something that happened that was significant was like Jack Dorsey provided a big donation to Oakland public schools to offer laptops to kids at home during the pandemic since they had to learn from home. So there's a lot of opportunities in crowdfunding that exist, and it's really exciting to see that. The second is voting. Right now we're in a crucial election in America, but across the world, voting is not just about uh, voting on a politician. It can also be voting for something that's happening in your community. For instance, housing authorities. Housing authorities have typically boards, and these boards make important decisions for the housing community that they represent, whether to, like, for instance, redo their local park, or to allow for certain neighborhood watches to be in effect, or to create certain standards and procedures, like the housing dues, because if you're in a housing association, you have to pay housing association fees, and then the community governs the overall community that everybody lives in. Those are some hyper local examples. Another example of voting could be like student governments, such as like people in college. When you're a part of a student government, you're typically voting on who you want to be your class president, who you want to be a part of your student body government, and then also on things that matter to your school. For instance, like you might want to support like a social impact project like climate change, and get behind that, and figure out ways in which you can do activism in your local college. And you might vote on that and ask all the students in your student body to also participate in that vote. So a DAO could represent something that essentially eliminates a middleman and then drives forward an initiative. In one scenario, it can collect funds and then distribute the funds to the right party. In another scenario, it could tally votes and essentially allocate those votes to the right initiative so that everyone is accounted for. And in blockchain, digital identity has been a huge topic, which we are now transforming the world with, so that more people can identify themselves on the blockchain and correlate their identity with not only voting, but also in transacting. So I'm going to talk to you about two platforms that we're going to use. And later today, this evening, I'm going to be, posting the links in the Discord channel to focus on, what tools we'll be using. But basically, to get started, there's an easy way to build a DAO, and it's called Aragon. Aragon essentially runs on top of Ethereum, and you can essentially create a DAO by just clicking on their site, and we'll give you the we'll be using a testnet environment. So in the testnet, it'll be a Rinkby testnet, and essentially you can connect your wallet, and then what you want to do is make sure you have a faucet, which we'll provide you a faucet with as well, so that you can connect your wallet, create an organization, and go through the whole flow. And some example DAOs that are out there already that you just quickly check out. There are some examples that are already out there, so that you can essentially do things such as assigning tokens, vote, check finances, look for allocations. So this is the Aragon mesh. This is the example project, and they had different votes that were already on the past. And an example vote that happened was this vote right here, is vote number 3, which is create an allocation account test. Obviously this is just all a test environment, but you can see that essentially they tested it to make sure that it worked for the use case. Um, Also, rewards are also distributed through DAOs as well. So to look for a reward, you can kind of go through there. So, there's a whole bunch of projects that have launched on Aragon, and basically through Aragon, which is not this version of it, but on the main Aragon, you can click on any one of these projects and essentially see what's going on. And this was really good because you can visualize a community, like what matters to the community, what they're voting on, their finances, everything. It's all transparent. So it's really cool because they essentially have passed all these different votes. Like, should we use Reddit for discussing specific proposals? And 52% said yes. And they have 14 votes, right? So with Aragon, you can essentially scaffold a DAO and literally launch it and deploy it. And you can see some of the votes have been rejected, right? So every time something happens in the community, they're creating a vote. Everybody votes, and then based on that vote, they tally it, and there's either success or a failure. And to go back, the finance side of this represents the overall liquidity of the DAO. Like, this DAO isn't that liquid. There's not a huge balance, but it represents about $17. But it's just enough to essentially do stuff with it. So basically, my bit is a new project. Never heard of it, so don't have too much familiarity with it. But essentially, like I said, we'll be using Aragon to work with the blockchain. They also have developer tools for DAOs. So when you go through Aragon, you can look at their toolkit to integrate a DAO into your front end. The whole use case that we're going to be building out will be building a DApp on top of Aragon. So basically, when you use the tool set that they offer us, it'd be something super simple, all JavaScript focused, so that you can use Web3 and JavaScript to connect your DAO, and then allow people from the DApp centralized app to take action, mainly casting a vote, fetching votes, or fetching token holders. Right? Those are some key functionalities. And then on top of this, what we'll be doing is to even take a step further. We'll be leveraging an app called Alchemy, and Alchemy is a environment for Ethereum development. They have a super node, and basically what they allow you to do is scale your blockchain DApp and connect it to their node infrastructure. So basically, you can utilize their API, and the API is pretty much super simple. They have a whole bunch of documentation around this, and all the main players in DeFi use Alchemy, such as MakerDAO, that is, Dharma, Kyber Network, and others like Shapeshift. And when you use Alchemy, you simply use Web3. They have a special version of Web3 that they've created a wrapper for. So basically, it's an effortless integration process to build your DApp on top of Alchemy. And basically, when you do that, you'll be connecting it to your own DAO. So once you deploy a DAO, it'll live on a Rinkeby testnet, and basically that will allow you to work with fake tokens, essentially, to use these test tokens with a test environment and build out your use case. So one of the most important concepts in this whole thing is that blockchain is a evolving topic, and there's a lot of needs that happen. So as you grow and build your DAO, you want to be able to create opportunities that represent holistically what we're doing. So that's it for now. So that's a quick overview on the DAO project, and basically we'll be able to dive deeper into that in the Discord channel. So Gideon, I'll let you take it from here.
Thank you, Joshua. Does anyone have any question? Please, if you have questions, drop them inside the Babylon DAO. So that's where those questions will be responded to. And then also, please feel free to build on the Babylon DAO. Develop what you want to do there. And then if you have any question, just leave it there, and then we'll be there to respond to you immediately. If you have a question now, we can answer those questions right away. I think Joshua can answer those questions right away, or he can reply you inside the Discord channel.
Yes.
let's wait for a few minutes and see if anyone is dropping questions in Discord.
Is this available to everybody? Like, is everybody could be listening to this, or this is just like, it seems like just a certain group of us here. I'm not
Yeah.
sure what the scope is.
No. So y'all, you got, I sent a calendar invite. Just let's talk directly later. But this is the live Zoom.
Okay, that's what I figured. Thanks.
If there are no questions, I guess we'll have more questions in the Discord. Checking Discord right now to be sure. Okay, no questions. We'll be back with the next workshop in a few minutes. Thank you, Joshua, for sharing with us on how to build good DAOs, and then we're looking forward to having developers build out in the Babylon DAO. Everyone, the teams are already open, so we have so many teams right now that have already applied. The teams are already open; it's visible to everyone. Please be careful and be mindful of other participants. Don't delete anything from other participants. Do not be aggressive. Do not be, just be a nice person, okay? There are people from different parts of the world for everyone. And so make sure to let us know which platform you're building on. You can build, any team can build on maximum 2 platforms, can try to deploy on maximum 2 platforms. And of course, we need working code with MVP and everything we mentioned for people to win. Again, try to build on using the tools from the sponsoring team. However, if you want to build on Ethereum, you can also do that, right? At the end of the day, we want to find a team that could win the hackathon. I mean, the DAO that Joshua just talked about right now, it's on Ethereum, right? It's built on Ethereum, on top of Ethereum too. So uh, it's the whole thing with the Babylon project. It's about the community. It's about people building solutions that can work irrespective of the platform, right? And so please feel free to make sure that you get into use any tool that you want. However, building with tools or you building using tools from sponsoring companies gives you an advantage. It's essentially in terms of like when we're considering the winners, because again, without the sponsors, you won't have prizes to win. So it will not be possible. But again, if you're building a great project, we really encourage you to keep building what you're building, right? Because again, the blockchain, the protocol that you use necessarily doesn't really that matter that much. What really matters is if it can drive real life use cases, if it can help people solve problems, if it could become a real company, right? That's it. Thank you, Joshua, and then looking forward to talking to you more in the Discord.
Yes, same. And one last thing I want to mention real quick. The value of why I mentioned Aragon, and really the whole purpose of this was that 1,500 organizations or DAOs have been created on Aragon already, and they've done about 350 million assets totally through crypto assets. So Aragon is a no code. Essentially, is like very little coding. You literally could just spin up a DAO fast. Where if it was on another platform, it could technically take a lot longer than 3 days to build out a DAO and test it. So just for the sake of speed, that's why Aragon was chosen, in case anybody was wondering about that. And yeah, awesome. So thanks for your time, and excited to see you all in Discord.
Okay, thank you.
Thanks.
Thank you, Samuel. The next workshop, it's going to be, we have the workshop that we have planned for today. We have a workshop from Suku, we have workshop from Aave, we have workshop from Polkadot, we have workshop from CryptoWork, we have another one just in general about smart contracts, right? Because we know that so many people are not used to smart contracts, and so it's their first time using smart contracts. And so we'll have a special panel on smart contracts to make sure that we have a special panel on smart contracts to make sure that people who are new to the blockchain will actually understand how to smart contracts. I always say that, smart contracts, to me, the easiest way to understand smart contracts is just code is law, right? It's just code, and then code is law. Okay, we'll wait for the next speaker. He's almost ready. Yeah, we will go on another break for 19 minutes. Also within this break, please make sure you are still in the groups inside Discord, and then where you should be forming your teams and joining teams. When you join a team, please be careful of the things you write there, so that you don't, because you can see other people's teams. So we're going for a 15 minutes break. I feel.
Hey, what's going on?
Oh, it's
I
doing
had
great. I'm
called earlier to jump into this. Are you? Did the workshop happen already? Is it done?
Oh yeah, it's already happened. Yeah,
How did it go?
we went pretty well. Yeah, it went pretty well. The next one should start in I think 5 minutes or so, or 10 minutes. So it's like this Zoom. It's for
It's for what? Sorry. Oh, somebody's calling.
Hi everyone, we're back to Zoom to continue with the hackathon and then the workshops. Luca, Suku, and then Garrett. Hi.
Awesome. Hey Gideon, how's it going? Thank you. Hey everyone.
Yeah, it's going
Thanks for joining the Suku workshop. Gideon, I guess we're good to go.
awesome. Okay, let's go.
Cool. Perfect. All right. Yeah, Gideon, thanks again. First of all, thanks to you and thanks to the entire team for organizing the Babylon Hackathon. Also, thanks to Zoe actually for reaching out to us. Really appreciate it and appreciate all the time and effort you guys put into this. For those of you that didn't have a chance to join the Suku intro earlier today, we're Suku, a supply chain and blockchain startup based out of Silicon Valley. My name is Lucas Henning. I'm the CTO of Suku, and I'm going to introduce the challenge that we have for you guys, and then I'll hand it over to Garrett to walk through a technical workshop. And so let me start screen sharing actually, and then I can show you the challenge that we got. I'm going to do that real quick. 1 second. Perfect. And you might have seen it on the call earlier today. So our challenge is build a DeFi application that helps farmers in Latin America. And honestly, personally, I couldn't be more excited about this challenge. It's a great opportunity to really provide value in the DeFi space. At Suku, we strongly believe in the power of DeFi. We strongly believe in the power of decentralization. And we also think that DeFi has so much like power, so many opportunities that are just waiting for us and waiting to get out there. And the sad story is that it's so much more than just earning 500% annual interest on a loan or something like that. So we really want you to build something that affects people, that has an impact, that really reaches people and farmers in remote locations. And we talked about the stack earlier today, so feel free to use any of the tools that are available as part of our stack. Garrett is actually going to tell you a little bit more about our documentation and what's available online. Garrett is going to talk about Suku Infinite in particular, but you can use any tool that is part of our stack. And even if you don't want to use a tool that is part of our stack, feel free to reach out if you have an awesome idea on how to improve supply chain, how to reach people with an awesome DeFi application. Just feel free to ping us on Discord. And now, without any further ado, I'm going to hand it over to Garrett. Yeah, over to you, Garrett.
All right. Thank you so much, Lucas. Hi, everybody. My name is Garrett Lee. I'm a product manager here with Suku. As Lucas mentioned, I'm going to be walking everybody through some of our documentation and doing a technical workshop specifically for our product called Suku Infinite. Just one quick disclaimer for everybody. Suku is not intended for US persons. So without further ado, let me jump right into a screen share. This is the Suku documentation for our various products in our product suite. I'll make sure this is shared liberally throughout the Discord channels, and if anybody needs it, It's pretty straightforward, just sukulab.github.io to navigate here. At a high level, there's a getting started guide. There's details about Suku Discover. There's information about Suku Link, Suku Carbon, which are all our products in our product suite. But what I'm going to go over today is called Suku Infinite, what I've spent a lot of time building and managing and navigating through crypto with. So the first thing I want to do is just level set on what Suku Infinite is and what it can do. Once again, this is not the only tool you have in your tool set when we ask all the hackers to build something for farmers to help bring DeFi to the masses. So essentially what Suku is it's a digital identity issuance and management platform designed for higher end products such as sneakers, apparel, and other accessories. It uses an ERC 721 smart contract, which is on the Rinkeby testnet. And I'll go to it really quickly. This is the smart contract you'll be interacting with, and I'll be interacting with throughout this demo. It's just a generic vanilla ERC 721 smart contract using the Open Zeppelin standard. So that's what we're going to be using to issue NFTs, manage NFTs, send them around, transfer ownership, so on and so forth. This product was initially designed, and these APIs were initially designed to accompany a mobile application. And this is what it looks like, just to give some context, where a user can verify the authenticity of their product. They can send the product to their friends. They can buy and sell products. They can access items on the marketplace, because each one of these products that has a digital representation in the form of an NFT also has a physical representation or a physical link, which is an NFC chip, an NFC tag that's used to affixed to the product, so that we can always map the digital identity to the physical product. So by no means are you limited with this API set to also have that physical element, but how this was originally designed and how we're using it in production today is to accompany physical products. So that's the gist of Suku Infinite. Happy to answer any questions you have about the product or about the concept in the Discord channel. So feel free to send those in. But now let's jump into the documentation and get a little bit more technical. So first, we use a lot of jargon with the set of APIs. None of it's overcomplicated to understand, but I think it's really important that everybody's on the same page when I use certain terminology so that we can understand exactly what's going on. So I'll just run quickly through this set of different terms that we use for these APIs. The first one is called an owner, and an owner is represented by an Ethereum public address, which can own NFTs, hence the name. The second is a product, which is pretty straightforward. It's something like this shoe we saw up here, but how it's represented from a backend, an API, and a blockchain perspective is it's represented by a unique ERC 721 NFT. A SKU is essentially a stock keeping unit, which is the metadata or tells us all about that particular NFT. So we know when we have an NFT on the blockchain, what type of product does this NFT actually represent? An ownership transfer is pretty straightforward. It's when an NFT moves from one owner's hands to another owner's hands. A report, which we'll get into in a bit more detail, is a safety mechanism. So if I lose my physical product, or if I lose whatever that NFT is meant to represent, and I want to disable any future ownership transfers of that non-fungible token, I can file a report, and that'll move it from a safe status to a lost status, which disables any future NFT transfers. And then the last term to know here are sort of the managers of the network, which we call verifiers. I'll give each one of you access to be a verifier here through the API documentation in just a moment. But these are essentially owners with special rights. They have the right to issue NFTs through the ERC 721 smart contract. So that at a high level is Suku Infinite and all the terms you'll need to know. Let's jump right into using the APIs. The first thing you're going to need to do is figure out how to get access to our APIs. And that's done through requesting an authenticity token or an authentication token, which is just a JWT. So this is an important thing to note. Our issuer for these JWTs is different than the other APIs you'll be dealing with. You'll issue an access token through this particular API endpoint, keycloak.suku.network/auth realm suku infinite protocol, etc. But every other API interaction you're going to have is going to be through this test network endpoint or set of endpoints, which is infinite-bc-backend-dev.suku.network. So we'll jump right into Postman and essentially show you how to issue an NFT. I've copied the exact command you need to execute here, and you can easily copy it to your clipboard and import it into your code or import it into Postman to issue the NFT. And I won't harp on this too long, but essentially all you have to do is hit this endpoint with this data, and it'll return this, this response, which is containing an access token, which you'll want to pay attention to, that expires in about 15 minutes. The rest, if you get more sophisticated with your application, you can utilize, such as a refresh token, so that you can continually get access tokens over a longer period of time without needing to do this HTTP request over and over again. But for now, all that we really have our eyes on is the access token. I've done a live transaction here on Postman, and I'll do another one really quickly, but you'll see here we get this access token. And I've run a script to embed this access token as a bearer token for every request we're going to have going forward. But essentially, all you would have to do is copy and paste it here in Postman or set it up in your code as an authentication header as a bearer token to utilize in future transfers and future HTTP requests. But just to let you know, you will get an access denied error anytime you don't have this auth token. So now let's look at what it looks like to structure an actual API request. So now that we have our access, we're ready to hit the APIs, and it looks something like this. Our main host is infinite BC backend dev suku.network, which we looked at earlier, and then we have various endpoints, which we'll go through in just a moment, one by one. And oftentimes we have different parameters, whether those come in the request body or the request path, so on and so forth, just depending on which API request we're looking to make. So the general structure of what we're going to do now that we have access is we're going to create a new owner for Suku Infinite by issuing a new Ethereum address to our network. So our network can pick it up and recognize it as, hey, this is somebody who's validated to now own Suku Infinite NFTs. After that, we'll issue a product through a verifier address, somebody who has that right to issue NFTs. Then we'll have a few ownership transfers and look at how the various ownership states work and the various ownership flows to transfer from one person to another. And then finally, we'll look at that reporting mechanism we mentioned in the original dictionary discussion at the beginning. So without any further ado, infinite owners, as I mentioned, are represented by Ethereum blockchain addresses, and these owners can own Suku Infinite NFT tokens. How we create an owner is a pretty simple and straightforward post request. We're essentially hitting this endpoint with a /owners and executing two pieces of information in the path. The first is the ID, which is the Ethereum address, and the second is a user ref, just in case you want to map it to any external account that you might have. So I've set up a transaction here in Postman just to really quickly go through. I was using a different address earlier, and I've generated a new address and key here that we can experiment with. So I'm going to copy and paste that into my form here. And essentially what I'm going to do is just press send. And what's happening in the back end is we're now allowing this user to own Suku Infinite NFT tokens. And we're also airdropping them a little bit of Rinkeby ETH because all these testnet transactions are going to be using Rinkeby, so that for your convenience, you can execute transactions without having to worry about hitting a faucet or getting your own ETH. If you do want to execute a bunch of transactions from a single owner and you're changing hands of these NFTs quite frequently, you might need to reload the initial small allocation of gas that we give you for various transfers. But here you can see we've received a successful response. And in our backend, we've stored this owner to now have access to the Infinite Network. So we're ready to move on, and we're ready to start issuing products to these owners. So now that we've gotten that out of the way, let's jump right into what it means to issue and have a product in Suku Infinite. Now that you've created an owner, we're essentially going to be interacting between various owners and the ERC 721 smart contract that I opened up earlier. Right here, it's just a generic ERC 721. Note, for creating a product, like I mentioned earlier, you have to have special permissions to hit the mint function on the smart contract that we've developed for Suku Infinite. We don't want any owner or anybody with an Ethereum private key to be able to issue NFTs on our network. So we have certain restrictions in place to make sure only people that we've permissioned as a verifier or a minter have access to do this. Since the account that you add and any key that you generate and any public address that you generate won't be a verifier by default, we've created a verifier in our backend for your convenience to sign transactions for you so that you can issue NFTs. So what does it look like to issue an NFT and create a product? And how does this all work? Well, we have the same endpoint, but this time the path is /products. We're still using the same access token, but this time we have a pretty large request body, and I'll go through a few of the key items in this request body. The first is the tag ID. This would be if you were issuing an NFT to represent a physical product. Unless you guys have a physical component to whatever you're hacking up here, I don't think this will be necessary. You can leave it blank. You can enter some dummy data, whatever you prefer. The second is the SKU, which is one of the terms I mentioned earlier. I've given a few example SKUs that you can use here if you want to issue various products. And if you want us to add any SKUs for any reason to our backend, I'm more than happy to accommodate that and do so. Just send me a message on Discord. Next is the verifier ID. So this is the person issuing the NFT. And the last and probably the most important is the owner ID. Who is going to be the recipient of the NFT? Normally, since we're just issuing a product, let's say it's a manufacturer of an original good and nobody owns that yet, we want the same person who's verifying it to also be the initial owner so that the first ownership transfer can be claimed by somebody else. Size is in here as well, not important, but if you're dealing with shoes or something that does have a size component, feel free to populate that. And then the last piece here is where we get into the world of blockchain and issuing transactions is this sign transaction. And we've set up dedicated endpoints so that you can conveniently sign transactions. This adheres to Web3 standards. So if you'd like to execute transactions through your own backend, or you'd like to execute transactions in some other way, you can read the Web3 documentation and understand how to do that. But we've set up some API endpoints to make it really convenient on you just for demo purposes. And just want to make a note and something very clear here, to execute these transactions and to have our backend sign it for you, you need to send the private key in the API request. This is purely for your convenience. This is by no means a good security practice, and by no means should this be done in production. This is simply to help you facilitate the signing of transactions and using these other API endpoints. So with that disclaimer out of the way, let's look at what it means to sign a transaction against our backend. First of all is the endpoint path that we need to look at. It's /BC/sign transaction. And then we look at the request body for signing this transaction. The first thing we need to figure out is which part of the contract are we calling. Right now, what's most important for us to call is the mint function because we want to mint a new FT and issue a new product. Second is the from parameter. This is who's actually signing and sending the transaction from a blockchain perspective. The third is a private key, which once again, you can use this particular private key as a dummy verifier. This one is validated against our ERC 721 smart contract to issue tokens and does have that minting capability. But please don't do this practice in production. Private key sending to API endpoints is not a good security practice. And finally is an input functionality. These are the parameters that go into the original contract call that you make up here. And for the mint case, this is the intended recipient of the token that's being minted. In this case, like we mentioned earlier, the person issuing the transaction initially and the person receiving the token is the same address. One thing to note when using this endpoint, this /BC/sign transaction endpoint, is it only returns a signed transaction. It doesn't actually execute anything on the blockchain. So now that we've gotten that over with, let's go ahead and execute one of these signed transactions. I'm going to issue a new authenticity token because they only last about 15 minutes. And now I basically just added in some variables here for the verifier address, the verifier private key, verifier address, so I can issue this call. So I'm going to hit send. And what we see is we've received the data of the expected message hash and some other information that the blockchain needs to successfully execute this transaction. Once again, this transaction has not been sent on chain yet. We're going to do that in this next step, but it is important to set us up so that we can issue a product. So jumping back into this product issuance API call, now all of a sudden we have our signed transaction, which was a missing component to issue a new token and to issue a new product. So what I'm going to do is hit send. I populated these variables with some Postman variables, so it's a bit more convenient for me and we can move along quicker, but you could copy and paste this transaction and send it without any issues. So I'll hit send, and this takes a little while to process because what's going on in the back end here is that signature that we gathered from this previous request is now being sent to the blockchain on Rinkeby, and it's issuing a new ERC-721 token. And in this case, it has token ID 735 with a verified transaction ID. So, and it has all the product information and details that we mentioned earlier and that we put in our request body. So let's hop over to Etherscan, enter this transaction ID, which we generated, and we can see 29 seconds ago, we issued a token with ID 375 under this smart contract, and it moved from the burn address, which is who's generating the token in this case, to the intended recipient, which is the verifier. So please note that this is a unique token ID, so 370 or 735 can never be issued to anybody else. It is unique to this product. If you're interested in what this looks like and how our mobile application would work, just want to quickly hop over here. Tangibly, this is how it would appear to a user if they were to scan the associated tag and look at this particular token ID. I can also send this URL to the Discord channel if you want to play around with it as you issue tokens and as you issue different products. But this is what a user would be expected to see, just to give some tangibility to what we're actually issuing. So all that information is captured in Postman. We have the ID for the product. We have the alternative product ID if we want to map it to a different application, the tag, the owner, so on and so forth. That's all captured here, and you can use to build your applications or whatever you intend to do with the Suku Infinite APIs. Now that we've issued a product and we've delved into the creation response, let's hop over to ownership transfers, which is probably the most essential component in Suku Infinite because it's really important. The reason we're issuing these products and the reason we're adding these owners and the reason we're managing all these identities is so that we can have traceability and we can have insight into the various NFTs, and in our case, the physical products that those NFTs represent. So it's extremely important that we have a way to map and reconcile what's going on in the real world versus what's going on in the blockchain world. So there's three primary states a product on Infinite can be. The first is unclaimed, which is the state of the product we just issued. Anytime you issue a new NFT, the associated product state will always start out in unclaimed. The second state is claimed. This is when it's kind of the default stable state. A product's been issued, it's been adopted by somebody, and somebody's claimed ownership over that good. And we can have insight from a blockchain perspective into who owns which NFTs. And then the third state is transferring. This is when it's kind of a pending state. It's gone from the, it hasn't left the current owner yet, but the intended recipient is now able to claim ownership of that product. So from a blockchain and smart contract perspective, let's look at what this means exactly. What we've done already is the verifier has issued a product via the mint functionality on our smart contract. That product is slated as unclaimed initially. What we're going to do next is make an initial ownership claim of this product. And we do this through the safe transfer from smart contract functionality, where the item is going from the verifier to whoever the initial claimee of this product is, whoever the initial owner of this product is. So what this would look like from a real world perspective, let's say, is somebody issued a NFT representing a pair of shoes. That pair of shoes arrives at the buyer's house. The buyer could then scan the pair of shoes, hit this safe transfer from functionality, and get that NFT associated with their product and transferred to have ownership claimed from their address. Once it's in this steady claim state, a lot of these products and a lot of these NFTs get transferred around in various hands, whether they're bought and sold, whether you're giving them away, whatever your case may be for your application. So to have this process complete and go back to this claim state, first we must hit this transferring state. And what that looks like from a blockchain perspective is we go from claim to transferring by hitting the approve function. This function doesn't actually move the product from point A to point B. It doesn't move it from owner 1 to owner 2, but it gives owner 2 the right to claim that NFT when they receive the physical product. So now let's say I've resold my goods. I give permission for the buyer of those goods to claim ownership of the product, but they haven't actually received the product. So we don't want to transfer the NFT ownership at the same time. We just want to approve them so when they do receive the goods, they can tap that tag or whatever your application looks like and have this safe transfer from function executed again so that it goes back into the claim state with a new owner this time. So that's essentially how the transferring and claim functionality works and what that looks like from a blockchain perspective. So let's jump into actually executing some transfer transactions and see what that looks like in our API set. So as I mentioned earlier, when a product is first issued, it takes the default state of unclaimed. This means it's still in the verifier's possession and waiting to be claimed. So once again, imagine a newly manufactured product is unclaimed by anybody because the verifier still has it in stock in their warehouse. Once it gets to the intended recipient, we need them to be able to claim the goods and the NFT from a blockchain perspective. So what that looks like is hitting the same endpoint with a different path. This time it's /ownership. And we have a different request body, but it does resemble what we did to issue this product. First of all, this request body needs a product ID. What product do we want this person to claim? You can get this product ID through a GET request. So if you ever want to look at the products available, you can just hit GET products and it'll generate all the products here that we have available. And you can see whose ownership, who currently owns them, so on and so forth. So once you have the product ID set up, then you can look at the action that you would like to do. In this case, we want to claim. Then we look at the owner ID. So this is the current owner. And then we also enter the recipient ID. Who is this being transferred to, essentially, which is this, and who is this being transferred, or sorry, to, which is this, and who is this being transferred from, which is this owner ID. In this case, you don't need a signed blockchain transaction because the one executing this initial ownership transfer is the verifier, which once again, in our backend, we've set up for your convenience to execute these ownership transfers. So let's see what that looks like in Postman. So I did create this new product. I'm going to grab the product ID, which I get from the response. I'm going to move over to my initial claim ownership. and update the product ID here. As I mentioned earlier, I have the action of claim. I have the owner ID, which is the verifier address, and I have the recipient ID, which I just have a variable here, which is owner ID 1. So let's go ahead and send that transaction. Once again, this is actually executing a transaction on chain. And since we're using Rinkeby and Ethereum, it does take a little bit of time to be processed. So essentially what's happening here is it's being transferred from this owner to this recipient. And we can see that this transaction is successful. We get a little bit of data here telling us what time it happened, what the transfer ID was, who the owner is, the product, the updated status. And as we saw earlier, this does issue a real blockchain transaction. We can go to the Rinkeby Etherscan portal, we can enter it and see 22 seconds ago, this blockchain transaction went through where we transferred token 735. I don't know why I keep messing that up today. 735 from the original verifier address to this new address through our generic token smart contract that we originally had. So now from an ownership perspective, we've successfully moved from this unclaimed state to this claimed state. Now let's say the goods get resold, and let's go through the process of moving it from claim to transferring and transferring back. This time, because each individual owner needs to be in charge of their own private keys, we don't have it set up in the backend to automatically execute a blockchain transaction for you. What you'll have to do, and what you did similarly in the Mint functionality, is sign a transaction on your end or sign a transaction through our endpoints to successfully execute this ownership transfer or to move it into a transferring state. So what this looks like from a post API request is we have the same endpoint, we have a different path, which is ownership, and we're going to basically put in a different request body. We're going to use the same product ID we used earlier because we're moving the product from the first owner now to its second owner. We're not executing the transaction right away. We're going to initiate and essentially prime the token to be transferred, because if we're shipping the product or it's a physical good or whatever the case is, we need some time in between when the product gets initially initiated for a transfer and when that ownership transfer actually happens and occurs. And then we have the owner ID here, which is the current owner of the product. We have the recipient ID, which is the new intended owner of the product. And we have the signed transaction, the Web3 type that we're actually going to use to issue a transaction on the Ethereum Rinkeby testnet. So once again, you can get this signed transaction through our backend by hitting this endpoint. You can do it on your own. You can do it through a different Web3 library. You can do it through however you would like to gather the signed transaction data. But for your convenience, we've set it up. Once again, do not normally send your private keys to API endpoints. This is for convenience and test purposes only. So essentially what we'll do here is we'll hit this BC signed transaction endpoint. We'll change the contract call. If you noticed earlier, it was a Mint contract call, and now it's an approve contract call because we're moving it from this state to this state. So initially we used this Mint function, and now we're using this approve function to move it from claim to a transferring state. We have the from, we have the private key, we have the inputs, which is who the recipient is, and the NFT. So let's see what that looks like from a Postman perspective. We've initiated the transaction and we saw it has been successfully claimed. Now let's sign another blockchain transaction through our backend, and we can see the response of this is all the information you need to execute this signed transaction right here and input it right here. I've automatically loaded and ported that in. All I have to do is update, oh, excuse me, let me grab my updated product ID here, update that, and I will post, whoops, sorry, wrong product ID. grab it here. And I will post an initiate transfer ownership request to our backend and also to the blockchain, which is taking the signed transaction data, what we got through this response, and issuing it against the blockchain. Once again, this takes a little bit of time. Looks like that transaction failed. Sometimes that happens. For Rinkeby, let's explore and see what's going on here. Maybe we need a new auth token. Let's give that a shot. And we'll sign this transaction. And here we go, successful transaction ID. We can see the timestamp, and we can also see now the ownership status is transferring instead of claimed. Now we've moved this particular product status, this product ID right here, from a claimed ownership to a transferring ownership. So let's jump on to Rinkeby and see what this transaction looks like from a blockchain perspective. We can see this contract was called by this individual, and essentially all that it did, I don't know how much data, oh, it called this approve function, which is what our intended attempt was. We wanted to approve the new recipient to now transfer the ownership to themselves. So the important thing to note here is the actual NFT has not changed hands yet. It's just been primed so that the intended recipient can claim it themselves from the original owner of that product. So let's complete the circle here and move from claimed to transferring. We already did that. Let's move back from transferring to claimed through the safe transfer from function. This is going to be a really similar process, so I can speed through this. But essentially, what we do is we update this a bit. So we have the same product ID. Now, all of a sudden, in our request body, instead of initiate the transfer, we want to claim and finalize the transfer. So this takes the ownership of the NFT and actually moves it to somebody else, which we'll see on chain in just a moment. We input the current owner ID, we input the current or the intended recipient ID, and then we sign a transaction, which once again, for your convenience, we've set up these endpoints that'll sign transactions for you. In this particular transactions case, we have a safe transfer from function because we're no longer approving, we're transferring from. We have who's executing the transaction. We have their private key. Once again, don't do this in production or on mainnet. And we have inputs, which are who it's going to, who it's coming from, and which token number we're using. So let's jump into this ownership transfer in Postman. We hit sign transaction, and we're given a new fresh signed transaction from our backend here. And we're going to post the ownership. I need to update the product ID based on what we just issued, token 735. And we're claiming it. We're moving it from owner 1 to owner 2, and we're using the transaction that we just signed. So let's hit that endpoint. And this is our third and final transaction for the demo. As we can see, we have a new transaction ID. This has been successfully executed on the Rinkeby testnet. Let's jump in just to see it, and we can see the ownership transfer has occurred. Looks like it's still pending. But yeah, essentially what this would do is it moves the NFT from user 1 to user 2. It's very similar to the transaction we had here from unclaimed to claim because it's using the exact same safe transfer from function where we're taking it from user A and moving it to user B. And looks like this is updated. So 25 seconds ago, we've successfully executed transaction for token 735. And if we jump into this token and this particular product identity, which is really what Infinite is all about, is being able to see all the hops of ownership a particular NFT or a particular product takes over time. So now we've seen that happen. move from the burn address to the original owner, move from the original owner to the new recipient, move from the new recipient to the individual who owns it now. And this is a test address I use quite often. As you can see, there's 111 current NFTs that this user has. So that's it for ownership. Those are the three primary states. There's a few more nuances that I'm more than happy to talk about if you choose to use Infinite on your solution, or if you have any questions in general, feel free to let me know. The last thing I want to show everybody today is the reporting functionality. So essentially, we've walked through what it means to be an owner, what it means to own a product, and what it means to transfer the ownership between products. But what happens, and maybe I should preface this with, reports are for physical goods only. If you've lost your purely digital NFT, then reports isn't necessarily for you, because as we all know, blockchains are immutable and you can't revert a transaction that's happened on a blockchain if somebody was able to compromise your NFT. But in the physical world, if somebody's able to compromise, let's say, your pair of sneakers, and they're chipped with an infinite NFC tag, well, essentially what we can do is disable any future ownership transfers. Or if somebody were to scan the product and see it, they would have a big red warning instead of item currently safe that this item is in the wrong hands, that this item shouldn't be on the aftermarket, it shouldn't be resold. So this is a mechanism we use to protect both the owner of the product, or the rightful owner, and protect any buyer to make sure that the product has a clean slate and a clean background. It's a pretty straightforward functionality. There's two different states a report can be in. The first is the default. It's the safe state. This is when a state is, or a product hasn't had any issues yet, or it's been in a lost state and moved back to a safe state. And lost is when a product is in the wrong hands and it has particular constraints on it, such as ownership transfer of the product is disabled and the products aren't accessible on the Infinite marketplace. So if somebody was seeking this particular pair of shoes and it's triggered as lost right now, then nobody could access it and nobody could inquire into potentially buying that certain product. One thing to note is if a product doesn't have any report information, which you might find on these APIs, let's say we look at the product we just issued right here through this get product endpoint. It doesn't have any report information. You'll see down here, there's no report anywhere in this response. And that's because we assume that any product that hasn't had a report filed against it is safe. It hasn't had any issues yet, and it hasn't had the need to file a report. We can also trace any sort of report history as well, which is very convenient. So let's just quickly move a product into a lost status just to see how it works, and then quickly back into a safe status. So to move it into a lost status, we use the same endpoint, a different path. We're going to hit this reports post, and we're going to enter the product ID. We're going to enter the action we'd like to perform, which in this case is lost, and we'd like to enter the current owner's address. If we have any of these off, like a certain product doesn't correspond to a certain owner, or the product's already safe and we're trying to report it safe again, our backend will send an error message and say that can't be done. So jumping over to my reports here, let me update this product ID with what we've been using so far and click send. And as we can see, this product has now been placed into a lost state. So if we were attempting to send this product or initiate a product transfer again for this lost item, we would get rejected by the Suku Infinite backend and say, hey, at this point in time, this product is not in the right hands, or the rightful owner doesn't know where it's at. Let's not let that product be executed, that product transaction be executed. And the last element we have for this particular reports endpoint is moving it back to safe. So we can hit safe, and this takes our product and moves it back to safe. Now, if we go in to get a product by its product ID, we'll see as we scroll down, it now has a report status that it didn't have when I inquired just a moment ago, and it's currently safe. It's currently identified as safe. And just to show you how the lost endpoint works, we can hit lost and get that particular product. Scroll down to the bottom, and we see now this product is lost. It can't have any future ownership transfers. And if we look at this product from a front-end perspective, it's reported lost. That's it from a high-level overview of Suku Infinite. As I mentioned earlier, I'm more than happy to answer any questions anyone has in the Discord. Would love to see what everybody thinks they can build with this. And by no means is this the only feature or tool we have in our development kit. There are several other mechanisms you can use, and I highly encourage everybody to explore it, whether you're more interested in supply chain journeys with Suku Discover, whether you want to look into tag management and tag scanning with Suku Link, or whether you want to look at environmental impacts and carbon emissions with Suku Carbon. I highly encourage everybody to dive into these Suku docs, build to your heart's content, and let our team know if you have any questions or any concerns or need technical support in any way.
Thank you, Garrett. That's been a very, very interesting deep dive on Suku, and it's very exciting because you made it very easy for anyone to easily build out using the tools you've described, and yeah, thank you for that. Again, all participants, we're expecting you to build lots of tools. I mean, Suku is pretty decent and the pretty good platform with a very good documentation. So it's pretty easy to use, as you've seen from Garrett. We'll be going to our next. Thank you, Garrett, again, and then.
Thank you, Gideon.
We'll be going.
Appreciate it.
You're welcome. Yeah. Where are you calling from?
I'm in Greenfield, Indiana, in the United States right now.
Greenfield, Indiana. Yeah. It's very interesting, like how we've been able to have so many people from different places calling.
It's amazing.
Share knowledge. Yeah, it's amazing. It feels really great. Thank you.
Great. Best of luck.
How is the weather there in Indiana?
Right now, it's perfect. It's about sunny and 70, but getting colder quickly.
Okay. Nice.
Thank you, Gideon. Have a great rest of the demonstrations, and I wish best luck to everybody.
Yeah, thank you. So the next workshop, would be with Andre. So this is BTCU. We have not had any introductions from them yet. However, BTCU, it's a very interesting platform that it's currently on testnet, right? And so Andre will be talking more about this, and then about the challenges, right, which the developers can actually win awards for finding vulnerability, right? Again, with the community, what we do is we try to see projects, and then we see, hey, can we de-risk projects, right? And then have people look through the codes, see if they can find vulnerabilities. Because again, this is one of the biggest problems. If there are vulnerabilities in codes, right, then we end up having cases where there could be hacks or something like that. Because again, everything that we have in blockchain is essentially a trustless ecosystem where we believe the codes. So I will leave it to Andre to talk more about the BTCU platform and why it's important. It's a new fork of Bitcoin that is yet to be rolled out, and why it's important, and then why the participants should work on it, and then why it's good for the ecosystem. Thank you, Andre.
Hi, can you hear me? Yes, everything is okay?
Yeah, everything is perfect.
Yes, my name is Andrei Saranenko, and I'm Operation Director of Bitcoin Ultimatum. And yes, now I talk about the BTCU project and actually what is going on cryptocurrency market actually right now, yes. Let's now I demonstrate the screen, okay?
Yes, please. You can.
That is okay? Yes.
Perfect. Yeah.
So I think that will be fine.
Yeah, everything is perfect. We can see you, and then right.
Yes, yes, right. So okay. Let's wait a second, please. Wait a second. So it's okay. Yes.
Yep, it's good.
Great. So what is the Bitcoin ultimatum? Yes, it's a next generation Bitcoin fork. Actually, it combines the best ideas and achievements of the crypto world. It's a decentralized ecosystem with a smart contract and anonymous transactions. The Bitcoin fork with a new mining algorithm, the BTCU, based on leasing proof of stake combines with proof of authorization. High bandwidth as well is many innovative solution which we provide for our users. And at the moment, we are preparing for the release, and soon we will present our fork to the broader cryptocurrency audience. So I describe the projects. Actually, in the market, cryptocurrency market now is development of the crypto industry is collectively linked with the development of blockchain technologies. And at the moment, the market is situated with several protocols, algorithm, and blockchain concepts that have contributed to the development of a wide range of services and application, offering users an alternative to both established financial system, applications, and service infrastructures. For example, the rapid development of decentralization, the popularity and continued growth is Defi. Defi segment opens up new opportunities for both businesses and users in the form of decentralized application for the exchange cryptocurrency and the development of financial service in the P2P. Um, the rapid development has created a number of challenges that the entire crypto industry is now facing. The major problems and challenges facing the industry are, well, the first of all, the level of transaction privacy, yeah, and the next and maybe a main problem of the crypto world now is the centralization is a big problem really now. But the next one is the efficient development of basic technologies in blockchain, the longer transaction time associated with the higher transaction fees, lack of comprehensive ecosystem in the industry. Actually, the big problem, the actually no big ecosystem which have the all advantages of the cryptocurrencies which users can um, use to for anything actually, but in the one ecosystem. So let's go one by one. And the transaction privacy level, actually, transaction anonymity is an old problem in the crypto world. However, there are very few projects that provide maximum privacy opportunities for user signs. Most cryptocurrency projects neglect this element entirely. With the development of modern technologies and the increased interest of society in blockchain technologies, in particular, the anonymity in the blockchain network becomes doubtful. Many networks already permit users to fully decode the chain of transaction from the moment of coin creation to the address where is currently located. The reason is the very structure of the blockchain, which is open actually. And lack of anonymity raises doubts about the foundation principle of blockchain as technology, which was required to use by Satoshi Nakamoto, the creator of the first blockchain network. Actually, blockchain is undoubtedly the best solution for anonymization, but questions is completely open now. Yes, it's not all full privacy right now. But the big problem in the market, perhaps one of the most prevalent problems in the is the network centralization. Decentralization is a long-standing market solution as protection against centralized projects and market manipulation, but many decentralized projects inevitably become centralized. It's nice to think that nobody controls a particular blockchain and network members act as a decentralized community that serves the blockchain and choose the direction of its further development. However, is not quite the case, actually. In the case of popular cryptocurrency using classical mining protocols, the equipment requirements are high even for simple information review on the blockchain. This leads to a situation where only companies with a large number of high performance miners can effectively create new blocks, as in the case of proof of work algorithm, which leads to centralized mining. It's a big problem, really. However, even if you have modern equipment that can quickly proceed blocks, your network channel may not be wide enough for faster synchronization with the network, or if some additional condition is in the case of proof of stake algorithm, the number of coins on the node balance is an essential creation for effective mining in the network. The issue of centralization has become a matter of growing concern, as it requires alternative solution to and consensus to address. The next thing is the popularization of the Defi. Yes, in case of popularization of the Defi, which has become widely used on Ethereum network, has led to a significant increase in transaction fees and slowdown um, of the network leads to an increase and fees of the network. Actually, this factor and increase in the number of transactions in the network leads an increase in load and fees in the network. Each validator is not quite up all unconfirmed transaction. So that is first confirms transaction with high commission. Obviously, transaction that fall at the end of the acquire may remain unconfirmed for a long time. The consequence of the unacceptance increase in the flow of the transaction is that the likely list of transaction awaiting to be recorded in the network. This is not only leads to manipulate increase in transaction fees, but also destabilize the network through the accumulating of dependent transactions. So what's the solution? The answer to each of that problems are already available on the market, but what we can choose? Currently, there is no coherent ecosystem on the market that would allow users to get a solution to one of the problems without sacrificing something else. Let's go one by one. Actually, anonymity. The most common solution is, to this problem is to use coin mixing service and add-ons that mix transaction of many users to hide the true history of transactions. However, such service suffer from a number of shortcomings as they need to be trusted in the coin return and maintain anonymity in the algorithm of the service. Moreover, a hacket of molecular service does not provide anonymity. The real solution to the anonymity problem in the blockchain protocols world is using protocols for anonymous transaction. The main advantages is the implementation of such solution in the network of the blockchain protocol as a native solution. This allows users to use them as normal types of transaction in the network and provide highest level of security. Example of such protocols Zero Coin Protocol and CryptoNote and Zcash Snarks. This is the best solution for anonymity right now. The next solutions, yes, of the big problem is transaction speed and commissions. The biggest aspect of the affects the speed of transaction for many cryptocurrencies is their fixed block limit. Almost every blockchain protocol has limit on the numbers of transactions per second they can perform at a given time, which cause a lot of hurt database between developers and users in the crypto world. Um, such restriction defined by the consensus of the protocol and this principle of operation, such as mining or other aspects of it. But two basic aspects are fundamental in the issue of capacity of the protocol and commission. The principle of forming the new blocks and the principle of mining new coins, which in most protocol are the same function. To solve this problem is necessary to form novel approach to these fundamental issues. The next is the development of basic technologies. Yes, actually, the really big problem because the reason of the inefficient scalability of the application of blockchain technologies is the inability of individual blockchain protocols to interact with each other. For example, to perform transaction between Bitcoin and Ethereum network is extremely limited, mainly because different blockchains use different protocols, algorithms, and security procedures. Different campaigns use the same blockchain protocols to solve same problems and cannot apply the same solution to other problems with which is the reason they do not use blockchain technologies in separate processes. Development of the possibility to interaction of different blocks protocol will provide an opportunity of mass introduction of this technology into business and social processes. As a result, the development of anonymous transaction protocol solves most of problem of network anonymization and solving the problem of capability of different protocol blocks will give an enormous boost to the mass application of the technologies, and the departure from the classical models of mining for extraction of cryptocurrency and the formation of the new block will make it possible to reduce commission and increase the speed of transaction, which will undoubtedly leads to an increase in the blockchain popularity. Following the example of other in other industries, actually, cryptocurrency is moving toward creating a unified infrastructure which contains all the preferred technologies and solutions without the need to sacrifice anything. So, what the solution on the example of our BTCU fork? We can easily see this in the rapidly growing number of forks and the creation of more and more new projects trying to solve the problems of previous ones. The role of forks in the blockchain place in the blockchain world, yes, an evolution role, allowing the industry to reach new heights and offer solutions that move the entire crypto industry forward. As Bitcoin fork, BTCU combines the experience of previous projects and perfect technologies. BTCU has its own ultimatum proof of stake consensus algorithm based on leasing proof of stake combines with the best proof of authorization solutions. The new decentralized algorithm solves not only the problems of the main types of mining, but it reduces transaction fees while increasing transaction speed, which also supports leasing. Leasing is an excellent alternative to classical mining and is the basis for network decentralization. The integration of Ethereum virtual machine technologies into the BTCU network allows the implementing smart contract on the well-known Solidity provides enormous opportunity for tokenization project or actually Defi implementation. Uh, Give its flexibility and scalability on the Ethereum platform is leader in the Defi application actually, but that doesn't mean it's the one blockchain platform. High commission problems with technical support of nodes, uh, oversupply of contract and centralization of the network, which is one of the most terrible thing for modern project, forced us to look for alternative solution or which is one which is BTCU. Is actually BTCU is based on zero coin protocol too, the technology that allows direct anonymous payments between parties. Private transaction exists alongside non-anonymous transaction. Each user can convert non-anonymous BTCU, which we call ZBTCU actually, to anonymous coins. Users can then send it to other users and split or combine the coins they own in the way that maintains the overall value. Users can also convert private coins that BTCU to BTCU and reverse, yes, without any problem. This is an excellent alternative to crypto mixers and similar solution because it provides a much higher level of privacy. Combining the solution with further integration of atomic swaps for exchange of all of types of BTCU coins within a single network provides an excellent basis of additional development and creation of compliant decentralized and crypto ecosystem. So actually that's intro. Yes, that's the main thing of BTCU and our goal, yes, in hackathon and our goal actually before the launch of the project is find all vulnerabilities and solution of them, yes, to make our platform more safety, more stabilize all aspects of the our blockchain because we combine much of technologies. Yes, it's privacy, it's zero coin protocols, it's leasing, it's our new consensus, and we need someone who help us to check. Yes, actually, fresh mind. Yes, which can help us to fix it all. Yes, and give to the world the best solution of blockchain technologies. Actually, in the smart contract, uh, the best and the big one thing which we need and want users test, because it's actually technologies which in the level like Ethereum network, yes, and actually it's not the one, but it's really cool to test. And our new consensus ultimatum proof of stake, it's something new, yes, which combine leasing and based on leasing actually, and we want to test it. So you can check our build by in github.com. It's you just can go here and you will receive all description how to all our build. Yes, then you can go to our check our RPC API. Then actually you have all the link, and we provide to you all the link and documentation. If you have some problems, or you can have access, or you can connect, yes, or you have some problems, or something else happened with you, you can contact us and request to hackathon btcu.io, and we will also support any issues in the Discord. I'm and our team answer to all your questions and provide all requirement and information to you if you want to ask, or don't worry, please ask and give. We want to discuss and find new solutions for our platform. So you can check it like this. Yes, PDF file that describe all our task. Yes, is searching for vulnerability in the BTC test. Um, uh, Actually, we have some rules. Yes, which uh, we do not think they are in the test net. Actually, all of this is test net. Vulnerabilities are not considered in test network as any attack related to the server resources or server architecture vulnerabilities or GUI bugs and interface related issues. Yes, it's not big problem in the test net, and we know such bugs, yes, in test nets which work with it, and it's just testnet, mainnet, and production version, which we prepared already, is much of problem fixed. But we need to find financial vulnerabilities, yes, which uh, may risks for users by financial in financial sphere. Um, Actually, the next you have all links to not write this. Yeah, you just copy in the PDF file, not in presentation. All requirements and description of how to build and to launch the node. Yes, how to connect and actually IPs of validation node and seed node, which you can use to help us to find a solution. Actually, that's the thing. That's all. I hope it was interesting for you. All questions you can answer to me in the Discord, yes, or in the mail. So, Giri, are you here?
Yeah. Hey, thank you, Andre, for talking us through the BTCU platform, which essentially is still on testnet. I mean, however, it's a very good time for you to start having all the tests, all the bounty tests, vulnerability tests, to make sure that actually developers can pre-build on your platform while you're on testnet, and at the same time try to find issues with the codes to make sure that when it comes mainnet, it should be able to function properly. The prizes again for BTCU, it's going to be in their charts. You'll be able to go there, see the problem statements, work to help fix this scenario, and then also help work to be part of this new ecosystem, essentially, right? Thank you very much, Andre, and then see you in
Actually, yes, all prizes. We thank you, Gary. It's really cool to be in Hackathon and describe about BTCU project. I think we can continue. Yes, yes. Actually, we have a lot of prizes. The first place is $500 in BTCU. We have 5 second places prizes, yes, for in $3,000 in BTCU actually too, and we have 12 prizes. This 12 third places, and which each of one receive $1,000. So thank you, Gary. It's really cool. Thank you so much. See you later. Yes.
Yeah, thank you, Andre. See you in the Discord. Okay.
Okay.
So
thank you so much.
okay, awesome. The next workshop, the next workshop is going to be on. Can you stop sharing your screen? I think I can disable him from the. Yeah, thank you. Yeah, so the next workshop is going to be by Ave, one of our sponsors. Of course, you've heard about from Ave from the introductions, and we'll be having a deep dive, a 30 minutes deep dive into Ave. All the recordings again will be provided in the Discord channel for you to look at them while you're building what you have to build. Now I will be sharing my screen so that we can go into Ave.
Hey guys, my name is David and I'm a developer or builder at Aave. And today I'm just going to be talking a bit about Aave and go through the basics of it for the developer crowd. So if you're a developer, definitely watch this video because we'll go through some of the basics. All right, so for those that don't know, Aave is a money market lending protocol. So what that means is on one side, we have the depositors and they deposit certain crypto assets into the Aave protocol. And then in return, they receive immediate interest. And that interest is earned based on certain parameters in the protocol, like utilization rate or how in demand a certain asset is used or wanted. And then on the right-hand side, we have borrowers. And so borrowers, they can either choose to take out instant loans at either a stable or variable interest rate. And then at the same time, they can pay back those loans anytime they want. And also, as I said, they receive those loans. And the important part here is that both the depositors and the borrowers, they can interact with the Aave protocol independently at any time, whenever they feel like it. They don't need to be matched up with each other. As well as the Aave protocol, we have one main market and also have another market, which we call alternative markets. And the Uniswap market is the first alternative market. What that allows is other types of crypto assets to be used as collateral. So if you're in the DeFi space and you know what Uniswap is, when you're a Uniswap liquidity provider, you also get these LP tokens, liquidity provider tokens. So the Uniswap market allows you to utilize those LP tokens as collateral in a separate Uniswap market. And we have plans for other markets as well, which I'll go through a bit later. Then of course, as well, we're quite famous for our flash loans, and I'll go through some detailed examples of that. So going over the main protocol features, during this presentation, I'll talk about earning, depositing, borrowing, credit delegation, and flash loans. But before we go into those, as you know, we support many different assets. We currently support over 20 different assets in our main RVA market. And then plus we have the multi-markets like the Uniswap market, which also supports more assets as well. So we've got quite a lot of assets to use. And so now I'll go through each of those major features, right? So for earning, which is basically, if I was explaining to a 5-year-old, you let others borrow your money when you're not using it. And if I was explaining to a 15-year-old, I'd say that you deposit your money and you earn immediate interest on that amount, and you can withdraw at any time. So very different from a traditional bank. And if I was explaining it to a DeFi person, I'd say that we tokenize your deposit, and as soon as you deposit it, you get A tokens in return, and A tokens are one-to-one pegged to the underlying collateral. So that means that when you deposit, let's say 100 DAI, you receive 100 A DAI in return. And the account that holds those A tokens accrues interest based on the protocol parameters, and it earns the interest per second immediately. So that's pretty cool that you'll be able to see your balance slowly tick up straight away. So from a developer's perspective, this is what it looks like. We don't necessarily need to go through each line, but I assume that you can sort of read this Solidity code and understand the basics of it. So at the top, we're importing just your standard ERC20 interface contract from OpenZeppelin. We instantiate a lending pool address provider instance of our contract. So the reason why we do this is because sometimes the addresses may change. So it's always good to get the latest addresses directly from the address provider. Right? The address provider address doesn't change though. So once you have the latest lending pool address provider, you can in the next line you can say get lending pool. So that gets the latest lending pool address to ensure that you're using the most up-to-date lending pool that we've deployed and that's being used in the ecosystem. And then after that, it's pretty self-explanatory. We basically we say what asset we want to borrow. In this case, it's DAI, mainnet DAI. We say the amount, and we have a referral code. So if you create something and it goes on mainnet and you turn it into a company or quite a large project, you can sign up for our referral program. So essentially, we give you a code that you can use in your website or project, and you receive some referral fees for helping users interact with the other protocol, whether that's depositing or borrowing. So there'll always be this referral code that you can insert. And of course, just like any other ERC20 tokens, before the user can, or before our contracts can withdraw the ERC20 tokens, you need to approve them, right? So in this case, we're approving the lending pool core address to withdraw tokens, to withdraw DAI tokens, right? And then the final line is the important line where we call the deposit function on the lending pool address, and we pass in the parameters that are the asset we want to deposit, the amount that we're depositing, and of course the referral code. And as soon as you go through those steps, and if that line passes, your contract or your user will immediately receive A tokens in return. And of course, as I mentioned, they're one-to-one pegged. So if you deposit 100 DAI, they'll receive 100 A DAI in return, and that will per second, it will just start ticking up straight away, and they're immediately earning interest, which is pretty cool. And so I mentioned that you earn interest on the account that's holding those A tokens. You can also redirect that interest. So let's say if you want to deposit you deposit your funds, but you don't want that interest for whatever reason, maybe you want to donate to charity, or you want to create a inheritance contract for your future son or something like that, then you can do that. You just simply call redirect interest stream on the A token contract that you're currently using. Super easy to do. So the next feature is, of course, borrowing. Right? And if I was explaining that to a 5-year-old, I'd say that we allow you to borrow money when you need it. If I was explaining to a 15-year-old, I'd say that you can borrow money depending on how much you have deposited in the system, and you can pay back at any time. So once again, that's different from the traditional finance system. And then if I was explaining to a DeFi person, I'd say that you can use your A tokens as collateral to borrow any of our supported assets. on our markets at either a stable or variable interest rate. And in different situations, you want to use the stable rate or the variable interest rate. For example, the stable rate is generally a little bit higher than the spot interest rate. However, let's say in the yield farming, in these past few months, the yield farming has gone crazy. Having a stable rate is actually really good because you can essentially lock in the interest rate that you'll be paying. Whereas a variable interest rate, a lot of times the spot variable interest rate is quite low or lower than the stable rate. But of course, it can jump in times of very high utilization, like what happened in the past few months with some assets like DAO, USDC. Sometimes they'd reach some crazy interest rates, 20, 30, 40%. And then they eventually settled down as well. Okay, so similar to depositing for borrowing assets, it's quite simple as well from a code perspective. We do exactly the same things as we did before. We get the latest lending pool address from the lending pool address provider. We have the parameters that we want to pass in, and then we say, okay, we want a variable interest rate or stable interest rate. In this case, the stable interest rate, it's an integer of 1, and the variable interest rate is an integer of 2. And then we have the referral code as well. And on the lending pool instance, we just call the borrow function, and we pass in the DAI address, or the address of the asset we want to borrow. In this case, it's DAI, the amount we want to borrow, what sort of interest rate we want, and of course, the referral code. And so to remember that to borrow assets, you actually need to have already deposited tokens in the protocol, because we're an over-collateralized protocol. So the user should already have A tokens set as collateral, and then they can start borrowing. And to switch between a variable interest rate and a stable rate, super easy as well. The top few steps are exactly the same as before. And then the last line on the lending pool, we just say swap borrow rate mode, and that will just swap it into the other interest rate mode that you're not currently in. One thing to consider with that is make sure that you do your research on the stable rates and how that works. You can check out our docs, docs.aave.com/risk, but also on the developer docs or the FAQ docs, because you can lock in your stable rate, but if you swap to a variable interest rate and then swap back to a stable rate, then that will change the stable rate that you're using, and that can sometimes be a better thing, but other times it can be a worse thing. So look carefully on those docs to understand it fully. Okay, so next I'll go through credit delegation. So far with let's say depositing or earning and borrowing, they've been basically you need to deposit to be able to borrow funds, and that's generally from the same user account, right? So they're intimately tied together. With credit delegation, we've separated those two actions. So now you can have a depositor that's separate from the borrower, right? And to explain it a bit more, once again, if I was explaining it to a five-year-old, I'd say that you let other people borrow money. If I was explaining to a 15-year-old, I'd say that you can deposit to earn on Aave, and you can earn extra by managing your own loans to other people. And explaining to a DeFi person, I'd say that we give others access to your credit line by depositing funds on Aave, creating a credit delegation vault, and you let them draw funds from that vault. And how you enforce repayment is really up to you. In some cases, you can enforce repayment off-chain through legal agreements or whatever else, or you can enforce it on-chain through your own smart contract. But the point here is that from the protocol perspective, the protocol sees it as just a standard depositing and borrowing, and liquidations will happen as they normally do. But then from your perspective, you're not using that credit line, so then you're giving it to someone else essentially, and they can borrow at will up to the limit that you set for them, and they will pay it back based on what you tell them, how you enforce it. So as an example, the first credit delegation happened recently with Diversify. They're a decentralized exchange. And essentially what happens in their case is they created an open law contract, which is an on-chain legal agreement. And once it's signed by both parties, then it automatically executes a payload. In this case, the payload was the credit delegation. And here you can see here, Karen, let's say Karen, the credit delegator, and Diversify, who's Chad in this case, they signed open law agreement. The open law agreement is executed. it executes the payload, which is deploying the credit delegation vault. Now the credit delegator can set the credit limit essentially on the vault, and then makes the deposit, and then therefore now Diversify has a credit line based on how much is already deposited in that vault, and they can draw that credit whenever they want. In this case, Diversify could draw a credit line using wrapped Bitcoin, which is very useful for them as a decentralized exchange, because they don't necessarily have to have these assets on their books all the time. They can just draw those assets whenever they need, and that can be useful for, I don't know, margin trading cases, or there's many other different use cases. Generally, it's used in more of a B2B sense, but also I'm sure there's other use cases that that can be more consumer facing. As far as I understand, Yuan Finance, the link vaults, underlying the link vaults, they utilize some form of this credit delegation as well. Okay, now for another big topic, another big feature is flash loans. So we have, once again, like credit delegation, we have a few examples. But so to separate the two, credit delegation is we're separating the borrower and the depositor, and the borrower essentially is can borrow money without any collateral, because they've had an agreement with the credit delegator. With flash loans, it's similar in that it's an uncollateralized loan, but there's no one else on the other side. It's very specific to how blockchains and Ethereum works. So if I was explaining flash loans to a 5-year-old, I'd say that it's free money. You have to pay back nearly immediately. If I was explaining to a 15-year-old, I'd say that anyone can borrow as much as they want, as long as they pay it back within a certain time frame. And if I was explaining to a banker or Wall Street person, finance person, I'd say that it's an unsecured fixed term loan for about 15 seconds. That's the block time in Ethereum, with a very low fixed interest rate, currently at 0.09%. The bank, in this case, the Aave protocol or the Ethereum virtual machine or the blockchain, it can always collect at expiry. So there's essentially no risk to the protocol or the underlying blockchain, just because of the way it's designed and the way blockchains work. And if I was explaining to a DeFi person, what it actually is, as I mentioned, it's an uncollateralized loan supplied by our lending pool, where the amount borrowed plus a small fee, the 0.09%, must be repaid at the end of the transaction. And why would you want to do that? Why would you want to take a flash loan? The main reason is that, or the only reason is that you can execute any arbitrary code while you have that money in your account. And if you don't pay back the loan at the end of the transaction, and then the state of the blockchain just reverts. So that means that time is essentially just turned back, and it's like you never took that loan, and then the protocol never gave you that money, and no money was lost, right? So it's very special in that sense. And I'll go through some more examples to help explain that. So here's a schematic of flash loans. The important part here is that the part on top of the purple line are the things that you'll see on the blockchain, whether or not the flash loan succeeds or fails, right? So that's where the associated gas costs will come. So the borrower will call some sort of flash loan function on the contract that will interact with the Aave protocol, and it may go successfully or it may revert, right? Everything below the purple line is the arbitrary execution that I mentioned before, where the contract or the user, they can do whatever they want. And if the flash loan is not repaid by the end of the transaction, then everything under the purple line just like disappears. It's like it never happened. So if we step through this, go on the top left from the start, the borrower, normally it's a smart contract because you need to generally code it. The smart contract will call the Aave protocol, the flash loan function. Let's say in this case, it asks for DAI, let's say 10,000 DAI. The protocol will do some sanity checks, and then it will send that 10,000 DAI to the borrower. And then the borrower has that block to do whatever they want with that 10,000 DAI. In this specific example, they're using that DAI to close a CDP, like a MakerDAO vault. They're using that DAI to pay it back, the debt, which will liquidate or release the underlying collateral, which is supporting that CDP. And since they now have the released ETH or the liquidated ETH, they can use that to sell on a decentralized exchange in the same transaction for DAI, and then now they have the DAI where they can repay back their loan, and maybe there's some profit or maybe not. And this is, I'll go through a reason why you'd want to do this specific example, because it's a real world example of closing a CDP vault. But before we go into that, this is what it looks like in code. So as a developer, you would deploy your own smart contract, right? And in your own smart contract, you would have a function, you can call it flash loan or whatever you want, and you would set your parameters. It's really dependent on your use case, but the important thing is the last two lines. Of course, you use address provider again to get the latest lending pool address. And then on the lending pool, you call the flash loan method function. And the parameters you pass in, the first one is where you want the flash loan money to arrive. So generally, you say you want to flash loan this certain amount to the current address, the current calling address. You say this asset, which may be DAI, the amount may be 1,000 DAI, 10 million DAI, however much you want to borrow is possible, as long as that liquidity is available in the protocol. And then you can pass through some data as well. And this is for later on in the next step. So when you call the flash loan function on the lending pool, our lending pool will do some sanity checks, like checking there's enough liquidity, that asset can be flash loan, that asset exists, and then once it's passed those sanity checks, it will send that asset that you requested to your contract, and then it will call specifically the execute operation function on your contract. Right, so you need to make sure that your smart contract has this exact execute operation function, and the signature matches this exactly, because our lending pool just calls this function. So once this function is called, you can assume that you have the amount that you requested, and then this is where you can do whatever you want with those funds. And you can see here at the end of this code, we just transfer the funds back to pay back the loan, essentially. So that's how easy it is. It may look conceptually a bit difficult to understand, but it's quite easy once you can wrap your head around it. We've got a ton of example codes and tutorials, and even a truffle box that you can just use really quickly to deploy flash loans. Check out our docs. I'll have some links at the end of this. But yeah, super easy to do. And as I mentioned before, the example, the flash loan will be closed down or pay back the debt of a CDP. Here's an example. It's actually called a collateral swap. It's actually something that I did on the weekend. So the collateral swap, what it's doing is it flash loans a certain amount, then it closes down a make a DAO vault, and it opens up another one, and da-da-da. But the actual important part of this is that something that would normally take 5, 6, 7, 8 transactions, we're doing it in one transaction. So we're saving gas costs, we're making it easy for the user. And also they don't need to have that debt to begin with, right? They can just flash loan it, then move that position somewhere else, which is quite powerful. And you see a lot more use cases of this. Defi Saver and a few other people are doing something similar to this these days in a much better way. And it's a real big time saver for a lot of people. Another example of using flash loans would be arbitrage. So it's quite an obvious one where you buy low and sell high somewhere else, and generally you need those assets already in your wallet. But with flash loans, you don't need those assets in your wallet anymore. You just flash loan them, then you can take those opportunities. So that's a pretty cool use case, and a lot of profit potential there. So next I'll go through what we call the Avenger fam. This is essentially our the people that are building in the ecosystem that somehow touch upon the Aave protocol. So whether it's building on top of the Aave protocol, including the Aave protocol in whatever you're building, that's what we consider the Avenger fam. And I want to go through some examples to show you what's possible when if you put your imagination to this, and you can build some really cool stuff, right? So Defi Saver, I mentioned them before, they're a really awesome product. They help you manage your DeFi positions in many different protocols. But the cool thing about them, I'll just highlight one feature, is that they have this cool feature where you can move your lending positions between different protocols. So that's really powerful, because sometimes on Compound, DYDX, or DSR, which is Make a DAO, or Aave, the interest rates are different, and sometimes the interest rate might be better on one protocol versus other protocols, right? And from a user perspective, you just want the best interest rate. So with DeFi Saver, they allow you to do a one-click move my loan position to this other protocol, and that's super cool from a user perspective. It's all done in one transaction. Normally, you'd do that, and you'd have to do 5, 6, 7 transactions to do that, and it's just hard to manage. They do it in one click, and underlying that is flash loans, Aave flash loans, which is really cool. So that's something they're a whole separate company, and they're doing quite well, and they have many other products. So I'd recommend you check them out for your own benefit, but also as an example of the really cool things you can build with something like the Aave protocol. Next, we have Furo Combo app. So I mentioned that flash loans, they're generally more developer focused, and you need a smart contract. Furo Combo were one of the first to build something, a GUI interface or a no-code interface for flash loans. And they did it really well, where essentially you just connect these blocks, like Lego blocks, and you say, I want to flash loan this amount, and then sell this on Uniswap, or create this position on Aave or Compound or whatever else. And they work with many different DeFi protocols, but it's just, they've done it, they've executed so well on this, and it's really opened up the opportunity of flash loans to non-developers. And from what I've seen, there's non-developers that are able to take these arbitrage opportunities using their flash loan tooling, their WYSIWYG tooling to conduct these arbitrage transactions, which is really cool, because I didn't really think that would be possible, but they've managed to do it, and they're doing quite well at the moment. So another example is Yearn Finance. So for those that don't know, Yearn Finance is a yield aggregator, and you can see their growth in total value locked has been crazy over the past few months. And the important part here is they aggregate yield over many different protocols in the DeFi space. Aave is just one of the protocols they aggregate. But the cool thing is that for some of the yield aggregation strategies, some of those funds end up in Aave. So it helps Aave's TVL, total value locked, but then also the interest earned on Aave is passed on to their end users. So from the end user perspective, they don't really care or know that their funds are being deposited in Aave, but they're getting all the benefit from it. And I think things like that sort of create just more choice and make it easier and better for users. And then a final example I'll give you, which is a bit different, is Aave Gotchi. They're a whole separate independent company, unrelated to the Aave team, core team. We know them through hackathons and whatever else. But they decided to create this a game. So a game just like Tamagotchi or CryptoKitties, and you go on quests and things like that, and you have this NFT that's proven a bit rare and all that. But underlying each Aave Gotchi is a bunch of A tokens. So that means that as you play this game and you're going on quests and battling things and collecting experience points, your Aave Gotchi has some inherent value, and it's interest bearing, right? So you're actually saving money as you play this game, which is pretty mind blowing. And I think they've done a really great idea they've executed really well on merging gaming with sort of something that's attractive to consumers with DeFi. So you don't have to necessarily do DeFi specific applications or projects. If you're really creative, you can merge these worlds. So I think there's a lot of potential there as well. Okay, now to wrap up, I'll go through some of the coming soon features, or maybe features that have just been released, just so you know, keep an eye out to the future. So as I mentioned, soon we'll have more markets. We've announced that we'll have a set protocol markets where you can use your set positions as collateral. We'll also have, we've announced a partnership with Realty, who tokenize real estate. So that will be a private market that we'll have eventually as well. But the point of this is that in the future, we'll have more choices, which gives you more liquidity for your tokenized positions. Right? So that's something really cool to look out for. Aavenomics, we announced that maybe like a month or two ago, and we've actually executed it. So a few days ago, we just migrated from Lend to Aave. It's still happening, but you can do it now if you have any remaining Lend. It's super easy, and with this Aave, it's our governance token, and there's staking and safety and ecosystem incentives that are included. So that's really cool. The special thing about the Aave token specifically as well is there's now a permit function. So I'd love to see developers building using the Aave token, using the permit function, because that allows gasless transactions and other pretty cool use cases. So have a look at that. And then also, of course, there's the staking mechanism where users can stake their Aave. So that's more yield opportunities for users as well, which is really cool. And we also, maybe a few months ago, we announced V2, and V2, we named it Seamless Finance. And there's a bunch of features, too many features for me to go through individually, but essentially there's going to be a lot of things that will make the DeFi space or the Aave protocol much more seamless. So like repaying with collateral or inbuilt trading mechanisms within the protocol. There's a whole bunch of things that are really exciting and should be really cool to build on, and for end users, like having a token on L2. We have a detailed post and a Twitter thread that you can look at as well, and more docs at the end of this presentation. And here they are. So I'd recommend, if you're looking to hack or develop on Aave, check out our hack documents, docs.aave.com/hack. Also on Discord, I'm on Discord. Someone from the team is always on Discord as well, so feel free to ask your questions there. We have, of course, our developer docs. All our docs are pretty elaborate. We try and make them very elaborate. So if you want to find out how to implement certain things using the Aave protocol, develop docs should be really good for you. If you want to learn how the whole risk parameters work, we also have risk documentation. So there's a lot of information out there. You just need to go read and find it out. Also, check out the Aavonomics paper if you want to learn more about decentralized governance and how the staking and security incentives work, because that might be important if you're looking to build on top of that. And then, of course, Aave V2, the blog post, which details some of the things that we have cooking away in the lab that should be out soon. All right, so don't forget to follow us on Twitter at AaveAave, or find us on Medium. And of course, check out aave.com if you haven't already. Play around with it. And yeah, we'd love to see you building and creating really cool things on Aave. I'm really looking forward to seeing what everyone builds and sort of just seeing the creativity that's out there. So yeah, feel free to hit me up anytime, whether on Discord or on Twitter and Telegram. I'm at DaveyT, DAVEYTEA. All right, thanks for listening and good luck with your projects.
Thank you. That was a good deep dive from Aave. We'll be going next. The next workshop will be from Crypto Work. Kevin again will join us to share more about what Crypto Work is doing. Aave is pretty interesting, especially showing some of the use cases where we've been able to see people use games. Again, these are not the standard thing for DeFi, but then applying such things, applying DeFi concepts in games. But I also agree with them. I think it's actually very, very interesting. These are the kind of concepts that we really want to see coming out from the hackathon, where people can actually build interesting projects in different industries. However, that could be coming from while using DeFi concepts. We will be in a 1-minute break while we wait for Kevin to join. Okay, seems we are back. Kevin is here, so we'll be starting the workshop for Crypto Work. Hi, Kevin.
Hey, how are you?
I'm good. Good to see you again.
Likewise.
The stage is yours.
It's all mine. All right, excellent. So great. I'm going to assume we have the full 45 minutes, but our API is really a pretty. The engineering team hates it when I say it's pretty simple. it's pretty simple once you understand what it does and how it works. It's two methods, and we should be able to go through it in that time. So what I'd like to do is maybe start first with, hey, here's our challenge. I'll describe what that is. Clearly, any other challenges or anything that the other teams have can use the API. Then what I'm going to do is walk through a little demonstration of what some of the terms mean, and as we talk about registering and hashing and that kind of thing. And then we'll just dive into code and look at, okay, here's some using kind of the Swagger, maybe some curl calls, that kind of thing. And then I'm not sure if we can keep it interactive. If people have questions, maybe via Discord or in the chat here, feel free to ask. But there are a couple things I'd like everyone to be able to do at the end. And that is, get an API key and be able to register a document and anchor it onto the blockchain and receive a seal, and then use that seal to verify that document hasn't been manipulated. So those are kind of the goals, and maybe the process we'll walk through as we go through this. So I am going to go ahead and share the screen. Full desktop, warning, danger. Here we go. And maybe we'll start with just I went through the agenda. We'll just hop to what the challenge is, just so anyone that might be considering doing our challenge. So essentially, what our challenge was kind of pointing at this huge problem of tax avoidance, specifically VAT tax in Europe. There's a huge problem because there isn't a way to really track that an invoice was sent. It was sent from a legitimate company. It was received, and that invoice is paid. So there becomes a real opportunity for fraud that could absolutely be reduced, maybe not eliminated, but reduced, if the invoices that were sent from one party to another, one enterprise to another, were actually sealed and signed and then delivered to, say, the buying company, and then on receipt, that those receipts or even payments are signed and sent back. So the idea is to sign, seal, and deliver, in this case, invoices or a PDF document. So an application that is almost like an inbox for sending and receiving documents, and then logging the fact that those things happened. So you've got this trail of immutability saying that, yeah, this was the invoice. You can't deny that it had been there, that it had been sent, because you signed the fact that you received it. So that's kind of the idea. And the API that we provide makes this pretty easy. It takes care of quite a few of these things. Yet it's an ambitious project. So we could, so if people have questions, we're going to be here all weekend to help. So that's the challenge. But let's maybe just jump into what is this that we're talking about. So first off, just so anyone that wants to kind of play around at home, or wherever you might be, at cryptowork.com, you'll need an API key, and you can do that by signing up here. It should be pretty simple. I'm just going to go ahead and log in, just to give you a sense of what the API is all about. And I said it's pretty basic in that it has two methods. One of them is registering. So give us a hash of a document, and we're going to register it and anchor it onto one or more blockchains. And we're going to then create a proof, or a mathematical proof that says it existed. We're going to return that proof back to the registration, the person who registered it. I'm going to actually switch accounts to my demo account. So one of the first things you'll see when you log in is that, hey, you get an account and there's some API keys, and you'll want to grab these API keys because this will be the thing that enables us to go forward. And quite candidly, this is probably the area we get the most inquiries about from a support perspective, is getting the API key lined up and done correctly. So I'm going to go ahead and show that in a second. But first, I wanted to just give a quick tour of what it is we're looking at here. So within this, we call this our app console. There's a little dashboard that says, yeah, we're status green. Our servers are up. I've got two particular accounts in this case. And this one account that I'm looking at is going to anchor data onto the Bitcoin test chain, Ethereum 4, which is a test chain, and what we call a Twitter ledger. So when I presented this morning, I had mentioned that we're a data integrity middleware API. So we take a cryptographic hash, so a SHA-256 of some data that you have. We take that cryptographic hash we bundle it together, and we write it to one or more blockchains, and then we return a mathematical proof. Our product is used typically for very write-heavy scenarios where you've got, say, a lot of data coming through a log, access logs, maybe it's price signals, that type of thing. Anything that you want to then later confirm that it existed in a particular state at a particular time, all we see really is the cryptographic hash coming in. And we return back this mathematical proof, what we call a seal. So I'm looking at the dashboard. I'm anchoring currently to 3 different ledgers. If you'll work with me and say that Twitter is a ledger, but in the olden days it was in fact that hey, the New York Times is where you had to prove that you had put up a job classified ad to show that you actually tried to hire someone in the United States before you went the visa route for H-1Bs. So the source of truth is a little bit in the eye of the beholder. Here for the hackathon, really we're talking Bitcoin, Ethereum. But we have about 21 different sources of truth in this particular case, no matter what they might be. So our API is really 2 things. And before I dive into the Swagger, I want to maybe show a little example. We created a Chrome extension, which you should be able to find in the Chrome store. I believe it's just CryptoWork will probably find it. But in this, it's just an example of what I mean by registering and anchoring. It kind of pulls everything together. This is just going to take a screenshot. So the screenshot is going to represent some data. That data I'm going to cryptographically hash with the SHA-256, and then I'm going to anchor that cryptographic hash. I'm going to send it to CryptoWork. CryptoWork's going to bundle it together and anchor it into those 3 chains that we just talked about. Actually, it's 2 chains in this particular example. So if I were to just take a screenshot, it says, okay, I got a screenshot. I'm processing the screenshot. I've gone from red to yellow, and eventually it's going to anchor and turn green. I'm going to go ahead and look at one that I just did a little while ago. So that's a screenshot that I took a little while ago, and we can see that's a screenshot. If I click it, we'll see, oh yeah, it's just some data up here, right? It's just a PNG, some data. And I'm going to, I've taken that data and it's been hashed, and we can see the digest of the hash right there. So that's the SHA-256 we're talking about. This is probably, if you're not familiar with blockchain, it's your first time, you're probably hearing this a lot, but the cryptographic fingerprints are a one-way mathematical function. So any data, any size can be, has a unique fingerprint that's represented as 32 characters, really. And that's pretty fascinating in and of its own right, that you can get any size data down to that. But this is, 15-year-old technology, SHA-256 open libraries that you'll find out in GitHub and on the internet. I've got a couple of pointers. If anyone has a problem to find that particular library, certainly we can help you get there. But that's kind of the assumption. CryptoWork is expecting in this SHA-256 hash, and then we're going to return back what we call a seal. So we just saw the document, and I said it ran through a cryptographic hash and created that digest. And I'm going to then take a look at this, what we call the seal. And the seal is returned as a JSON object. And it says some things like, okay, I've got a particular date. I've completely registered this. In this case, I've got a couple of different proofs. So every blockchain that we anchor this hash into it gets a mathematical proof. And that mathematical proof is kind of the link between the original document and an anchor hash that you find out in a public blockchain. So in this particular case, we're on Ethereum, and we anchored into a particular transaction block, and you can see a timestamp, and it was the document hash from the digest that I just mentioned before. So that digest, we compressed it by taking hashes of hashes and kind of putting them together, and it goes down to those 32 characters every time. So no matter how big the data was, we compress that down and create these proofs. So we've got the original document hash, and we're saying in this particular proof, hey, if we take that hash and we prepend this hash, which is just some random hash out there from other people using our services, some randomness that we might insert, and we come up with what's an anchor hash. And it's this anchor hash is the only thing that you find out on a public blockchain. So this seal here with these proofs become the link between your original document, represented by its hash, do the math, and you get down to an anchor hash, and that's what's found in the public blockchain. So you get the properties of the blockchain, but we do this compression to enable the throughput of writing data to go way, way, way up. So we get, a million plus to one compression, if you will, which can also bring down the cost of writing to a public blockchain by those factors as well. And we do that in an extremely high-speed inbound process. So the first thing that people do is they call our method, which is called the register method. And that's that register method that's going to take in a hash. CryptoWork is going to bundle it and return this entire proof. And out on a blockchain, you're going to find a particular anchor hash. I'd love to know if people can have questions, want to take questions, or if you just want me to keep going. I'm going to continue, but if anyone raises a hand or has a question, certainly let me know. So let's take a quick look then. Coming back up to the plugin, we just looked at we looked at the document, we looked at the seal, we saw that JSON object, and we could go ahead and look at, okay, where in Ethereum, in a block explorer, if we look for that particular blockchain transaction, we should find this particular anchor hash. So we can go ahead and open those validators, and it's opening quite a few, and I'm going to hopefully find Rinkeby here as soon as these resolve. And that's Bitcoin. Yes, I think Rinkeby. And we can see that it's gone to the same blockchain transaction. And if we look in the down here, we should see that we have a 1BFB, and that should match the anchor hash. Actually, the 32 characters there should match the anchor hash from our very first the screenshot and in the seal, where we said we were going to go out to this transaction ID. We're going to take that document hash. We're going to perform a hash of hashes, and we're going to anchor this 1BFB out in the blockchain. Right. So we do all this this math. We take care of all of the wallets. We take care of worrying about finality and heartbeats and all of the complications of writing data, a sidechain or an anchoring onto a blockchain. We take care of that and abstract it all. So all you have to do is call an API with sending us a cryptographic hash. That's really kind of the simple parts of it. And then, as you can see, we just did kind of an independent validation by saying, hey, if we have anyone that has this particular screenshot, this document, can take that document, can hash it. That's kind of the first check. Does the hash match? You don't even have to go out to a blockchain to know if the data has been manipulated, if the hashes don't match. So that's kind of step one in data integrity, is just do your hashes match. Where the blockchain comes in is for, hey, did it exist in this format at a particular point in time? And because we're taking that anchor and putting it out into public blockchains, you can imagine every node of Ethereum and every node of Bitcoin in this case. And we also tweeted it, let's say. So all of those act as this kind of source of truth that, hey, there's 30,000 plus different nodes around the world that knew this document existed at a particular point in time. And it's not that they know that this picture existed. They only know the anchor hash. And it's the seal that gets this picture to that anchor hash. That becomes this link to the source of truth. So you get the properties of the blockchain without putting data on the blockchain, and you get throughput by using the bundling and calling CryptoWorks API. So I want to maybe move a little bit further into, let me close some of these windows. I want to go ahead and head into maybe into some code and how do we actually do this? And I'm going to just go to VS Code for a second and maybe start up here. What is it we're doing? We're taking some data and we're going to SHA-256 hash it. That's getting its cryptographic fingerprint. We're going to then take that hash. We're going to call a register method. And then CryptoWork is going to return from that register call a 200 with what we call a retrieval ID. This is kind of your first link to the blockchain. So this hash is going to get a retrieval ID, and that retrieval ID is going to eventually have the cryptographic proofs to go with it. So once we've got that, our next step is, hey, we've registered the hash, but we want the seal. And there's two ways to get that seal from CryptoWork. One is you can call our API for retrieving, and that was what we call polling. And we will then send back the seal in whatever state it's in. If you remember, since we're anchoring on multiple blockchains, they're going to have different times that their heartbeats go. They're going to have different times that they get finality from a proof of work perspective. And you don't have to worry about any of that. We're always going to return to you the most recent version of the proofs for those blockchains. So when you poll, you would have to keep polling to make sure that, hey, when do I really feel safe that, say, Bitcoin's proof of work isn't going to be forked? Well, maybe that's 6 blocks later at 10 minutes a piece. Maybe it's an hour or so. So on a proof of work, you want to wait until you've got that finality and that security that there's going to be no forks. So polling can have its challenges, but it's super convenient from building example apps. But better is to use what we call a callback. And in the callback, you simply say, what HTTP endpoint or message queue do you want us to deliver the seal back to you? And we will deliver that seal every time a blockchain confirms. So Ethereum, you'll see first, and then you'll see, say, 10 minutes later, you'll start to see the proofs come in from Bitcoin. So this is a super handy feature that you always know in your application that you're going to have the most recent and stable proofs because they keep coming in. So I want to just show maybe the register here, and then I'm going to move over into the Swagger API, which has a few additional options. But I'm in VS Code right now, and if those familiar, I have the VS Code REST extension going right now. So that's why you don't quite see a curl command, but it might look a little bit like it. And what I've done is I've taken my API key, and hopefully you can't see the very end of it because I'll have to reset it soon. And I was saying that one of the hardest parts is figuring out that our API key that you're going to send in your post call, your post calls, will be our API key with a space and then the API credentials. So you can kind of see that I got this little space there. This is all in our documentation, which I think I will just point you to right now. If anyone is following at home, let's go to docs.cryptowork.com. And here you will see some quick start information, some tutorials, right, and some additional information. If you get stuck on anything, if it takes more than 5 minutes, drop a message into the Discord and we will help to get you unstuck. So, so that's one place to get the docs. If you are in the dashboard, you can also get to that by hitting the documentation link here, and it'll bring you there. Okay, and there are some code samples, maybe just while I'm giving the tour here. It seems I closed it. Let's get back to the documentation. Down the user guide. So the user guide will give you some examples in various languages if you want to see the Java equivalent or JavaScript and so on. You can go ahead and use those. You guys are probably familiar with that kind of stuff. All right, so back to VS Code. So I'm in VS Code. I've set up my API key, and in this case, I've got my base URL that I'm going to call, and we're going to go through all this in the dashboard so you can see where you pick up yours. But I'm going to perform a register hash, and you might recall up at the top here I said first we're going to take data, we're going to SHA-256 it. In CryptoWork land, from our perspective, we only see SHA-256, so you've got to get there yourself first. And that shouldn't be too hard. There's a lot of libraries out there that you can use. One of them is Crypto.js. And what you'll do is you'll probably include something like this, and then you'll make a call that is something like this, where you'll SHA-256 your document or your data, whatever it is. In this particular case, it's just a message that they've got here. But that's the idea. So we're going to make an assumption that you're only sending us SHA-256. And you're going to call our register API, version 8 register. You're going to send in an API key, content type, and an acceptable format. In this case, application JSON. And you're going to send in those 32 bytes. In this case, it's a hash. And I said that that's really all we want to see. So go ahead and hit that. We can see we've got a 200, and that 200 has returned, in this case, since I have only one hash coming in, it's returned what we call a retrieval ID. And that's retrieval ID is the first link saying, hey, CryptoWork is creating proofs for us. Your application can now use this retrieval ID to pull for those seals and get those proofs back. So that's a very simple way to get data in. I want to take this one step further, because getting data in is great, but you might want to add some metadata to it. So for example, this hash might represent some document in your database. I have to move, there we go. This might represent some data in your database, and you might want to use what we call lookup infos. Right? And this is just, oops, let's get the lookup infos, and maybe this is some kind of record number, right? Like a customer record number for, so it's a ABC customer. It's an invoice number 1, customer invoice 1, something like that, right? So you can add some metadata to it. And then again, I'm just going to register it again. It's because we're processing and bundling these transactions up, it brings the cost down. So I can start to register everything that moves, right? Not just invoices, but every time an invoice is sent, I can take the metadata of that being sent and register it. And if I didn't do anything wrong here, yep, we got a 200. So I've now just added some metadata to that particular call. And I have a retrieval ID, which is that first link. So let's go ahead and take a look at if we take the next call. Okay, so we've registered a document. It's CryptoWork is bundling that and is taking care to get it out to Ethereum and out to Bitcoin. And we can go ahead and retrieve the seals for that particular retrieval ID just by calling the verify method. All right. So again, instead of curl, I'm using this REST API extension in VS Code. I'm calling the CryptoWork API version 8 with verify, and the parameter I'm sending in is the link to that document via this retrieval ID. So I go ahead and hit enter, and I get a 200, and this is where we get the seal back. And as we saw with that Chrome extension, that seal has a list of proofs in it, right? So that seal kind of starts right here. Right? It's got some document info. We can see it's got some lookup info that I said it was for customer ABC. It's invoice 1. And then we've got the mathematical proofs. And these proofs, let me see if I can, right? These proofs are saying, hey, in this particular example, I've actually anchored, if you will, the anchor hash out into Twitter. And I've taken this documents hash came in, it was SHA-256. If we want to see the anchor hash, we take that hash, we prepend another hash, that gives us another 32 character string, which is what is represented down here. And that anchor hash is what we'll find out on the Twitter ledger. We'll find that out in Ethereum in this particular block, right? And so on. And you can see that this is what we call the proof, right? And that's the proof for, in this case, Ethereum and Twitter went at the same time. And it's not done yet, right? So our API is saying, hey, it's not quite complete because I'm still waiting on Bitcoin, which has got a 10-minute heartbeat. So I can still move forward. I still have proof on these other kind of sources of truth, if you will, these other chains. But I don't have it complete yet. You'll see this complete once all of the blockchains come in. And when you sign up for a developer account and get your API key, you'll have 2 by default, and that is a Bitcoin test chain and an Ethereum test chain. But as I said, we have about 19, 20 others as well, right? In this return, there's also some additional information about where it was registered. And we kind of think of these as validators. So if you wanted to go see this tweet on Twitter, we could go ahead and click and see that tweet at CryptoWorks seal status, and we could find this particular anchor hash. And again, the seal is the link between the original document and what's posted publicly, just an anchor hash. Right. And the same with Ethereum, if we want to go out to Rinkeby. And we saw this as well when we were on the Chrome extension. So that's sealing, that's retrieving the seal via its retrieval ID. And now what I want to do is I'm going to go over to the Swagger interface and show you a couple more options. And now you actually can do a verify. But maybe before I do that, I wanted to talk about one thing. I said, hey, you can go poll and get the seal from CryptoWork, or you can use a callback. So I want to go ahead and register, not just with some metadata, this lookup infos, but I also want to add something called a callback. And will I ever remember to put the quotes? Let's see. And I want to, I'm going to use, I've got to cut and paste it from down here. Yeah, let me just go ahead and use this. I've got a little callback set up. And I don't need to type that. So I have a little callback set up, which is saying, hey, I'm going to use an HTTP callback. I'm going to send JSON plain text, and I'm going to just call, in this case, it's from Pipedream. I'm just going to call an endpoint that they've got set up. So it can receive the seals every time that they're confirmed on the blockchain. All right. So I've just added another parameter here so that we can start to say, oh, that's going to go ahead and post. And we should see a 200 over here. And we have a 200, and we got a new retrieval ID. So let's just take a look out here at this callback, right, out in Pipedream. And it's always in the way, the Zoom. But if we look at request bin, I did it a little earlier. And just to give you an idea, what you're going to see here is what you might expect. We said you could either poll to get the seals, or we can send them to you. We'll deliver them via the callback. So what the payload that's hit, in this case, the request, or I call it request bin, but it's now Pipedream, is the seal. So that same information that we talked about in the seal, where it's got the various proofs, they roll in. In this particular case, it looks like what rolled in first was, I think if we see it here, we're going to see the Twitter ledger rolled in, and we might see that Ethereum rolled in, but we didn't see here any Bitcoin at 305 when I ran this. But 10 minutes later, go figure, Bitcoin had rolled in. So CryptoWork redelivers the proof to the callback. So from an application perspective, assume that when you get a callback from us, that callback should be the next, or the one that's used, the most valid. So I hesitate to say delete the old one, but this would be, you want to always use the most recent seal that we deliver. All right, and it looks like we've got a seal from the one I just did here a few minutes ago, and we can see that the seal is rolled in. It has a couple of proofs, and it looks like it's come in, and it's probably the Twitter and Ethereum that's rolled in first. So that's I think an important concept, and certainly it's incredibly helpful from an application developer's perspective, because you just have to wait for the seals and receive them. You don't have to worry about did I poll for the most recent. So while polling is easy to do, callbacks will guarantee that you've got the most recent. You don't have to worry about the timing. All right, so I'm gonna take a breath. I know I don't see any questions, but that's okay. So I'm back in the app console, and I want to now talk about, okay, how do we verify, right? So we've created these proofs, cryptographically hashed a document, we've registered it, we've got a seal back, either by polling or by callback. How do we know now, if we hand data to somebody, some third party, how can they know that that data existed at a particular point in time and hasn't been manipulated? Well, we give them the data and we give them a seal, and they can by themselves figure out if this data has been manipulated or not. And they can do that programmatically by calling an API, or they can do that with a little hand calculator to say, hey, let me look at the seal, let me do a hash. Okay, hash of hashes, what does that equal? Do I find this anchor hash in the blockchains? If I do, I know it hasn't been tampered with. So you can do it by hand, or you can do it in an automated way. And I want to kind of dive in a little bit to that automated way. So first, a quick tour of the API Explorer. It's just Swagger, some information that we just talked about polling versus callbacks. about API credentials. Again, key point, don't forget the space between your key and your API secret. And then I said that the developers hate it when I say it, the engineering team that is, when I say it's a simple API. It's got two methods. It's got register and it's got verify. Somebody can call me out and say I'm fibbing a little bit. I see a third one, which is true. This one is a little housekeeping admin. Should you use a callback and the callback fails, we'll keep trying for 24 hours every 5-10 minutes. And if you want to clear the queue, you can use an API to clear the queue. But let's stay on the happy path. All right, we did register over in VS Code. So I'm gonna just point it out here really quickly again. The point I want to make here is you drop in your hash. Your hash is what gets sent to us. And you can have more than one hash. In this particular case, I've got an array of hashes, in this case, all ones and all twos, and I have no idea what data that represents. We can have multiple metadata, one for each hash. So in this case, lookup infos, not just lookup info. I'm just going to leave it blank. And this is where we could enter the callback that you saw me enter in VS Code, where I hit the pipe dream. So you can either hit an HTTP callback, or if you're using message queues, you can subscribe to a queue. And the instructions are right here in the Swagger API. I'm going to go ahead and hit execute. And here we should see that we have a 200 with 2 retrieval IDs. So that's how fast it is to register something. This is your first link to a blockchain proof, is this retrieval ID that comes back right away. And it's this retrieval ID that we can then use in the next API call, which really does 2 things. So I say it's simple. This is maybe the second complication beyond getting your API keys correct, is that the verify method actually does 2 things. It does the polling, which we just saw and talked about. Give me a retrieval ID, I will give you its seal. And it does something called verify, which it's named after, which is give me the hash of a document, original document, and give me a seal, and I will tell you if that data has been tampered with or manipulated. So I'm going to go ahead and first, let's see if our retrieval ID from the one we just did, right? If that comes back, let's see, it's probably still processing. Okay, it's hit Twitter and it's hit Ethereum, so it's probably enough for us to get going here. So I'm going to go ahead and take this seal, right? And again, it's the seal and the hash of the original data that, when compared, will tell you if the data has been manipulated and that it existed at a particular point in time. So I said that this verify does 2 things. We just polled for the seal. Now I'm going to actually use the seal, right? So I'm kind of scrolling down here and it's saying, hey, this is the start of the second group of operations this API call can do. And I was like, okay, good, I want that. I'm going to take that seal I just had, and I believe that was for hash 1. I didn't look, but we're gonna see. It was either hash is all 1 or hash is all 2. And I'm going to go ahead and hit execute by sending these 2 parameters in. It's going to now check, and if I have copied everything correctly, I see a 200, and it's come back and said, yes, I've verified that the hash you sent in and the math on this, in this seal, when I go through and I take the document hash and the hash, prepend another hash, and I get down to an anchor hash, and then we actually go out and do a blockchain explorer to see, did we find in a particular transaction ID, in this case on Ethereum, did we find the anchor hash? And the answer is yes. So we return here, yes, it's verified, it's true. You might be seeing here that we have is complete false. This is showing up false because the Bitcoin hasn't yet done its proof of work yet. When that proof comes back, it will also be included in the verify. So you're not only verifying, did this anchor hash exist in a transaction in Ethereum, you'd also be verifying, did this exist? Did the anchor hash that got into Bitcoin, did that verify as well? So that is the kind of the rundown of the API. I know that's pretty quick. I heard something come in terms of questions. No, I don't see any, but if there are any, this would be a great time to ask. But that's the kind of the happy path of running through. First you hash. Let me come back to my VS Code, right? Take the data, hash the data. Take the hash, call the register API. And again, CryptoWorks not going to see any personal identifying information. We're going to see a cryptographic hash, and we're going to see a little bit of metadata. Typically that metadata will be, okay, what row in a database or table do you want to put the seal into to be near that original data, right? So if you have, say, an inbox full of invoices that are PDFs, you might have a document that goes with it that's the seal with that invoice number. All right. So then when you go to send an invoice to somebody, maybe you're getting audited, the invoice and the seal kind of prove that, yes, I invoiced at this particular date and time for this amount to this particular buyer. I invoiced them and I collected this much tax and VAT at that time, and here's the proof, here's the seal. So then any third party could independently verify that. We're pretty excited about this because this is where auditors, folks like PricewaterhouseCoopers and others, can get into a place where they're doing continuous audits, where they're getting the proofs and hashes and validating that, yes, they've got a particular audit for, say, all of accounts payable or all invoices and so on. I think this is really going to be a transformative business process as it relates to that industry, as more and more companies get digitized. And as I said earlier today, our vision is that eventually all data, be it at rest or movement, will have a proof that goes with it. And it's that proof is what we're creating here at CryptoWork. And that becomes possible when you bring the throughput up, millions of hashes per second going in, and you bring the cost down by factors of 1 million. So that's the idea here. So hashes come in and register, you retrieve via poll or callback, right? And again, you always use the most recent. Because of the different heartbeats, you'll get proofs that get continuously updated. Ethereum will come in first, Bitcoin will come in, 10 minutes later. And then, of course, you can verify the data as I showed. A hash of the data with the seal. You make an API call or get out a pocket calculator, which I don't encourage, but can be done, and you can verify it by yourself. How are we doing here? I'm gonna hit pause. That was kind of the quick happy path through. There are various options that you can add to both calls from there, but to get through the challenge, which maybe that's where we end up. If I go back to, I believe it was right here, right? The challenge was, hey, create an app that signs, seals, and delivers. In this case, invoices from one party to another. And we talked about sealing here. Signing is something that's done before you hash, right? So you can put a cryptographic signature onto a document, and then you can hash that and seal it, right? So while the challenge is sign, seal, and deliver, any portion of that, be it seal and deliver, sign, seal, and deliver, be it using some type of identity service. I think we've got something listed in here, like a MetaMask or something, where if you want to use your Ethereum public address, you could use something like that to do the signature and the verify. That's all possible. We have, we're judging for a couple of things, creativity, originality, using the technical implementation of our API, which is 2 methods. And then if you use these other things, it's kind of bonus points, right? If you use some kind of key manager to sign, if you use something like GunDB, if you want to actually store that data in a distributed database. And I say these things that could be a lot for a weekend project, but man, those things are, Gun especially, Gun and its security library C, simple drop-ins. And the MetaMask Web3 for Ethereum, simple drop-in for sign and verify. If you haven't gone there yet, don't be too intimidated. There's some great tutorials out there, and it's really simple JS add-ins. You can get them off a CDN, and it's just like one call to sign and another to verify. So super simple there. Just ending again, documentation, docs@cryptowork.com, get an API key at developers@cryptowork.com. Okay, I'm stopping. How are we doing? Any questions? Anything else I should cover?
Yeah. Hi, I'm Kevin. Thank you, a bunch of people have said that they like the platform already. In fact, someone has already did registrations yesterday looking into the platform. So he was able to get all his keys properly, and then everything was nice. There's also another question coming around. How do you think what's the best way to actually build an app that basically does certification, right? So one entity issues a certificate, right? And then how do you think it's going to be best built using your solution?
So let me make sure I understand the question. I think you're asking about signing, yeah, how we get to sign and verify.
Yes.
Yeah. So not a simple problem, and it's not that crypto work. It's not that our solution does that. We do data integrity. We provide the proofs. That's why I was saying, like, hey, MetaMask takes care of the private key exchange. Of course, you're taking a dependency there that your users on both sides have MetaMask, which for this particular hackathon, that's not a problem, right? Not a problem at all.
Yeah.
And that's actually, I think, where I'm kind of hoping we see some activity and some folks doing that. So if that's the case, as long as the app, let's say it's a web app, right? As long as that browser extension is in, you'll have access to private keys to do signing and verifying. Does that answer your question?
Yeah, that does answer the question. Yeah. Thank you so much, Kevin, for the workshop. Again, we'll post all the materials in the within. It's already posted in the Discord, and then we have one more workshop, and then one more. I think two more workshops, right? Two more workshops. One on smart contracts. The speaker is from Sydney, and then one more by Polkadots, and that will be all talks for today. And then we can continue talking on Discord, and the team formations are going on. We have about 70 teams now. And so keep chatting with your team, keep building. If you have questions, please don't forget to ask. Thank you, Kevin.
Right.
Yeah.
Take care.
Yeah. So the next talk, 1 second. Yeah.
And welcome, Babylonians, to this technical introduction workshop for the Babylon Hackathon. My name is Bruno, and I'm a technical educator at the Web3 Foundation. And this foundation is the one that's spearheading the Polkadot and Kusama projects, and also some other things, as you'll learn. In this introduction, I would like to talk to you about a fun project that I'm currently working on, and hopefully use that project to inspire you to kind of become creative hackers in your own right, because this project in particular uses some fairly unexpected logic to bring non-fungible tokens to the Kusama blockchain, which by itself doesn't have any smart contract logic, which means you can't really do any advanced computation on the chain itself. Now, to unpack what all of this means, we will have to start at the beginning, and we'll go through all of these terms so that you finally, at the end, understand why I've done what I've done and why I'm building this tool set. And hopefully, this will inspire you to play with substrate-based chains in a similar manner. And I'll explain what substrate-based means as well. So let's get started and explain and start at the very beginning. So first, what's an NFT? Well, every blockchain has its cryptocurrency, and that we can call cryptocurrency a token, right? So even Bitcoin is a token on the Bitcoin blockchain, Ether is a token on the Ethereum blockchain, but also Ethereum supports a lot of other tokens that are built using smart contracts. And every blockchain has its own version of tokens, both native and smart contract derived. But in essence, a token is just a currency represented on a blockchain in a specific way. By definition, these tokens are fungible, which means that if you send one Bitcoin from one person to another, that Bitcoin is not actually, those Bitcoins are interchangeable, right? One Bitcoin that I get from Alice is interchangeable with one that I get from Bob. Of course, there is this transaction monitoring and checking if the Bitcoin came from a stolen stash from an exchange or something like that. And this kind of reduces the fungibility, the interchangeability of these tokens. But in essence, one Bitcoin will always be equal to one Bitcoin. And this is the domain of fungible tokens. And before we move on into non-fungible tokens, it's worth pointing out that when we're talking about tokens on a blockchain, it's very simple. It's much easier to think about them if you visualize it as one big Excel sheet. And that one big Excel sheet has a column that has the list of users, and then there's another column that has a list of balances. And all the miners in a blockchain are just constantly keeping an eye on that one Excel sheet. And you as a user have the ability, the permission to only change the value of your own cell, and you can only change it downwards. You can only change it by subtracting from it. And however much you subtract from it, you can add to somebody else's column, or somebody else's cell. And if you do that, somebody else's balance will increase and yours will decrease. Now, what's preventing somebody from doing that willy-nilly to anybody whenever they want? Well, exactly those miners who are looking at the spreadsheet at all times. So everybody's checking that the changes that everybody is making in the sheet are valid. And whoever makes an invalid change just gets kicked off the network. They lose permission to edit the spreadsheet, right? So this is how you can visualize token balances on a blockchain. Now, in non-fungible tokens, you have the exact same thing, but the entries are much richer in data. So for example, if we have something like a token that represents a samurai, and those samurai are collectible illustrations of samurai. And now one samurai is green, the other is red, another is blue, and so on. But these entries in the spreadsheet will have multiple values. They will have these descriptors, like which color they are, what skills they have, but they will also have their owner. So just like with the balances on the fungible tokens, they have this balance has this owner, this balance has this owner. The non-fungible tokens also have their owner. And the way you trade them is you just change the owner, right? You just edit the owner field, and then suddenly you've moved that NFT, that token, that non-fungible token to somebody else. So what makes it non-fungible? Well, every samurai is unique, right? Every samurai has its own serial number, as in when it was created, and is unique in some attributes. Now, there may be two blue samurais, but one of those will have been created before the other, and their serial numbers differ. So in effect, they are unique. And this is what makes them non-fungible. One samurai does not have to be equal in value or utility to another samurai, right? And non-fungible tokens are actually collectibles on the blockchain, kind of collectibles, art, concert tickets, certificates. There are many uses for non-fungible tokens. And one of the most popular uses right now is art. So artists will tokenize their work, and then when you buy the digital version of that artifact online on a blockchain, the token gets transferred to you. Now, what's the point of that? If anybody can just copy and paste the image, right? Well, the point is, for one, the reproduction rights. So you can sell the copyright to somebody else. Two, you can have royalties so that you will get a percentage of every future sale of this artwork. And also, there's no real point in owning a physical painting either, right? There's no utility to it. It's a collectible. And maybe it has some value attached and you can sell it later. But it's the exact same story with digital collectibles. So with an NFT-based artwork, you can not only have it and speculate with it, but it can actually have utility in other applications, contracts, and so on. For example, imagine a video game which will have a unique sword, and then you have that sword in your crypto wallet. Now you can apply it to your character in a game, But you can also apply it to another character in another game if that game connects to the blockchain on which your sword resides, right? So you basically have usable items that you can transfer from game world to game world. Now we've expanded the use of NFTs. Another use case is if you have a art piece in NFT format, imagine virtual worlds with virtual galleries in VR, and then you can just put your NFT into that virtual gallery in that VR world, like Decentraland or a similar project. And so now we've actually gone into this kind of human computer hybrid world where people actually have these alternative living spaces which they can decorate with the collectibles that they've bought on chain. And because these collectibles are unique, non-fungible, and basically bound to their account, there's no way somebody else can easily steal them. If this were a game which resides on somebody's server, that person who owns the server could edit the information in there and display the same items you have, right? But since this is all blockchain powered, the system has no choice but to respect the rules of every account. So if I have a painting, somebody else cannot have that painting, unless the painting has been developed in such a way that multiple copies can exist. Those are then fungible, non-fungible tokens, and it's a whole other can of worms. But these are just some of the uses of non-fungible tokens. Others are certificates, diplomas, concert tickets. There's a whole bunch of applications for non-fungible tokens that that really benefit from this permanence on the chain and from this ability to take them with you in your crypto wallet. So, okay, non-fungible tokens are valuable and they're all the rage on Ethereum. But what if we have a different chain that doesn't have NFTs yet and that doesn't even have smart contracts? How do we bring NFTs over to that chain? Such is the case with the Kusama network. And the Kusama network is the, okay, let me rewind a little bit. So Web3 Foundation is building Polkadot and Kusama. And Polkadot and Kusama are both substrate-based chains. Now, Substrate is a framework for building blockchains, and you might get exposed to it through this blockchain hackathon because it's a very, very easy and efficient way to get started with your own custom blockchain, application-specific blockchain. This framework gives you a nice foundation for your blockchain. In fact, if you just clone it and run it, you already have a blockchain. And then you can just add in plug-and-play functionality to it that already exists in plugins called palettes. And these palettes you just pull in, add as dependencies into your node, and your node, your blockchain node, will get upgraded with that extra functionality. So you can customize your blockchain. But you can also develop your own palettes for truly custom scenarios for your blockchain. And that's where the power of Substrate shines. So Substrate is this foundation on which dozens of blockchains are already being built. But Kusama and Polkadot are two that are live. And now, Polkadot is actually this blockchain that's intended to be the communication hub for all other blockchains. Polkadot is kind of like this chain of chains through which other blockchains will pass messages. So if I connect Ethereum to Polkadot and Bitcoin to Polkadot, I can very easily and in a safe and decentralized way send Bitcoin onto Ethereum so that I can actually use Bitcoin for something, right? Bitcoin is useless as it is. It doesn't have any functionality, any smart contract functionality. It's very expensive. It's very slow. It's basically just gas that pays for itself. But if you move it to Ethereum, you can use it in DeFi. You can use it to get loans. You can use it for all sorts of things on the Ethereum space, which are not possible on the Bitcoin blockchain. And right now, you have some means of doing that transfer, but these means are all very isolated. So you have something like TBTC, which uses an incentivized group of nodes that will take custody of your Bitcoin and then mint a token on Ethereum. Or you have WBTC, which is wrapped BTC, where you rely on a centralized custodian to take your Bitcoin and mint a token. And these are all very separate solutions. It feels kind of disjointed, and you get two different tokens. But if you connect them through Polkadot, you not only allow Bitcoin to go to Ethereum through Polkadot, you allow Bitcoin to go anywhere through Polkadot to any chain which also connects to Polkadot. And that's the big seller there, because you can also pass messages from the Ethereum connection on Polkadot to any other chain. So you're basically joining this information superhighway where all the chains can communicate with each other, and all the chains are application specific. All right. So Bitcoin is this digital gold. Ethereum is this general world smart world computer. There will be DeFi chains, NFT chains, gaming chains, and so on. And so you can move assets around from chain to chain. And these connected chains are called parachains. Now, this functionality is not yet enabled. And in fact, Polkadot, as the stable conservative chain, is slower to upgrade. It's playing things safe. And that's why it has Kusama. So Kusama is a canary version of Polkadot, which is more chaos prone, more edgier, friendly to experimentation. And it's not a testnet, it's like an experinet. It just wants to experiment with different features, different abilities before Polkadot inherits them. And maybe sometimes Polkadot doesn't get them at all. And so with Kusama, we get these edgy use cases that we can test, but Kusama also still doesn't have parachains. And it doesn't have smart contract logic. It's just this core chain that's waiting for other chains to connect to it. And while we wait for native solutions for NFTs to come to Kusama, because a lot of people are using Kusama already, I figured, why not force Kusama to have NFTs? Why not put NFTs on Kusama regardless, despite there not being any logic to support them, so that people can get started making NFTs. And then when bespoke solutions come up, like a parachain specifically for NFTs that can talk through Kusama to other chains, why not use this solution that I can hack onto Kusama without breaking anything? And so this is where Remark comes into play. And before I go into Remark, I want to encourage you to really look at Kusama as your experimentation ground for this hackathon. So it's kusama.network, and it's a very chaos-friendly network where you can build a lot of different things, even though you wouldn't expect to be able to do so, because a lot of the functionality isn't there yet. But you can still hack around it, as you'll see very soon. So what is Remark? Well, every substrate-based chain, and that includes Polkadot and Kusama, has a set of pallets or modules that perform some operations that let you execute some functions. And you call the functions in that chain by issuing extrinsics. So what's an extrinsic? An extrinsic is an input from outside the chain into the chain, which causes an action. Now, it's like a command that you execute and that has an effect on the chain itself. So when you send a balance to someone on a substrate-based chain, you will send the extrinsic that says balances transfer. And the balances transfer extrinsic takes two parameters. It takes the recipient and the amount. And when that's sent to the chain and signed, the chain will look at that extrinsic and will apply its effect to the state. So the balance of the recipient will change if the extrinsic is valid, or the extrinsic will fail and you will still be charged the transaction fee because you still spent the chain's resources in order to attempt this and to emit an error event. So extrinsics are like these commands that you issue to the chain. The chain will charge you for them, whether or not they're successful. And the output is either an error if you send an invalid extrinsic, or a change in the chain state if it was valid. In fact, the state will change regardless because even errors are logged in a way. So what does this have to do with anything? Well, there is a special extrinsic called the system remark extrinsic. That means that it resides in the system module, the system palette, which is the core palette of every substrate chain. And remark is the function on that palette. So it's like a class and then a method on that class. And now The system remark extrinsic is basically a blockchain graffiti. Whatever you send into a remark gets emitted into the chain. It isn't stored on chain in any state, but it's I don't know how to put it other than streamed into the ether of the chain. It's literally graffiti on blocks. So by sending a system remark, you basically send any bunch of data into the chain, and every node will be aware of that data that you sent. That data will not have an effect on the chain state. It's not going to save anywhere, but it will forever be visible as an artifact on the block in which you sent it. So if you inspect that block where you sent that extrinsic, it will forever be there. Your action will be logged in as an input to the block forever. And by doing this, you can actually send arbitrary messages into the chain, which others can then read. So you can send these messages onto the chain, and they will be propagated to all other nodes that are connected to the chain. And then you can use tools like the Polkadot.js API to connect to the blockchain node and read those extrinsics back out. Now, this is much, much slower than just reading the chain's current state. So it's not practical for high volume applications or anything advanced, but it's very handy to hack something onto the chain which shouldn't be there. And that's what I did with Remark. So Remark app is, and you can visit this website by going to rmrk.app. Remark app is a way to get non-fungible tokens onto Kusama. And so how do we do this? Well, we have some standards. And if you go to the top of the page, I recommend you scroll through this entire website and read the examples and explanations. But what it comes down to is, in order to get an NFT, you have to define its structure so that other applications reading about that NFT know what to expect. If they come across a bunch of data, they have to know if it's, I don't know, an image of a turtle or a JSON file that describes what an NFT is. And so I wrote some specifications that document how an NFT and its parent collection need to look in terms of data. And so every NFT is part of a collection, and you define a collection by setting a JSON blob, which will say how many, let me increase the font a little bit, by saying how many tokens this collection can contain, what the symbol of the collection is, who the issuer of the collection is, what the ID is, what the name of the collection is, and the link to some metadata. The metadata is another JSON element hosted on IPFS, and it can contain arbitrary amounts of data. This is external because it is very expensive to save such values on chain, right? The more bytes you send, the more you have to pay. So it's cheaper to just include a link. And in this case, it's a link to IPFS, which means that this link cannot go down. And then once you have a collection, you can define an NFT inside of that collection. And the format for defining an NFT looks like this. You have a link to the collection it's a part of. You have the name of the NFT. You have whether or not it's transferable. You have the serial number of the NFT. And again, you have some metadata. And this metadata can contain some other stuff. All of this is defined in the specification. And so by defining these simple standards for NFTs and their collections, you can emit these in the form of a remark onto the chain. And then anybody who reads these remarks will be able to see who and when created some NFT collections and some NFTs. But just creating an NFT and a collection isn't really doing much, right? It's kind of pointless. Well, that's why we have some interactions defined as well. So interactions are interactions between the outside world and NFTs and NFTs and NFTs. For example, you have here the mint interaction, which will let you create a collection. But you also have the buy interaction, which lets you buy somebody's listed NFTs right from the chain. So in order to list it, let's check out the list one. In order to list it, you would get a specification. Let me increase the font here as well. In order to list an NFT, you would emit a remark that looks like this. So you can see here the standard for listing your NFT for sale is defined as remark and then colon, colon. Then you have the list as the name of the interaction, again, colon, colon, version of the standard you're using, colon, colon. And then you have the ID of the NFT that you're selling and the price. This is denoted in the smallest possible unit of the chain that you're using currently. You turn all of this into bytes and submit it as a hex value. So this is basically this. And as long as you submit this as a remark onto the chain, and the tools for the remark suite can read this remark and find it later, you will actually be able to visualize that somebody has listed an NFT for sale. And then if you try to buy this token, you can see here the standard for buying it. So the standard is defined as hash, as hex of bytes of remark, buy, version, and then the ID of the token you're buying, and the transfer of the tokens required by the price. So in this case, we use the utility batch extrinsic. And the utility batch extrinsic is a functionality that allows you to put different extrinsics together and then execute them at once. In this case, we are going to batch together the remark that says I'm buying and the transfer of the list price. And so you get this basically. You get this by extrinsic, which converted into bytes, you get this. And then you also get a transfer. So this is something like what it looks like in JavaScript. You batch together two transactions. One is the remark of our buy interaction, and the second one is our balance transfer. And by using these two together and sending them, we have basically hacked on trading onto Kusama. Even though Kusama doesn't have native token transfers and it doesn't have smart contracts, we were able to force it to allow trading of NFTs. And now, to recognize this change of ownership, there's another problem. How do we read these remarks? And this is especially problematic because as these interactions get piled up onto remarks in the chain, we have to keep track of the state as they pile on, and we have to recalculate the final state at every step of the way, because nothing is preventing anyone from issuing this type of transaction, even though they're not allowed to. Maybe I'm selling my token for this much, and maybe somebody decides to remove this many zeros and submit this regardless. Will their transaction succeed? Yes, but it won't succeed in the eyes of remark, because the specification clearly defines that the price has to be equal to or greater than the list price that we define. And to list, we have to define the price like so. So we have the hex, bytes, remark, list version of the spec we're using, that's 0.1, ID of the token, and price. So price has to match whatever we're sending. And this is why it's important to have standardization of tools so that these tools can all agree on the final outcome of all of these remarks when they find them and process them. This is the challenging part of remark. So in practice, we have the following two repos you should check out if you want to get inspired and hack your own stuff onto this. The first one is the specs repo. And the specs repo will document the specification, the standard for entities and interaction. So entities are NFTs and collections. And interactions are mint NFT, consume, change issue, send, buy, and list. So these are all interactions that you can do with your NFT. In the relevant folders, you will see that, you will see in the standards folder, you will see that these are all documented. So if you go to interactions, you can see them all here. And here's the mint interaction. How do you mint a new token? You emit a hexacoded value of the remark that says remark, mint, and then the JSON of the collection you're minting. Once you emit this, your collection will have been created. So these blueprints, these standards are what implementers should use when they're building their own tools for remark. And while we're on the topic of tools, we have also here the tools repo. This is a very, very early alpha, and I've only submitted a couple of code changes here that are not exactly meant to go live in any way. I'm working on this actively right now, so please don't fret if it's broken or something. But anyway, this tools repo will be the first official implementation of the specification for remark, so that these can be implemented into wallets and UIs and so on. And this will automatically sync to the latest state of all remarks on the target chain where you're adding NFTs, in my case on Kusama. And let me actually demonstrate some of this right now. So if we go to this chain, so this is my development chain. I'm running a local copy of Polkadot on my computer. And by copy, I mean I just cloned Polkadot and then I ran it in development mode, which means it ran from block 0, and it comes with some accounts that have money that have been pre-seeded for development. You see here, Alice has a bunch of unit, Alice Stash has a bunch of unit, Bob, and so on. So these accounts have money that is for development. You can see here under Network Explorer, you'll notice that we're getting blocks, and we're at block 9,000. And so this, if you click on a block, you will see all the extrinsics that happened in that block. There you go. 2 extrinsics have been set. Timestamp is set in every block so that we know when a block was created. And here we have finality hint, which I won't get into right now. But essentially, excuse me, every block has a set of common extrinsics. Now, let's try and submit a remark. So if we go to developer extrinsics, you will end up on this screen. On this screen, you can select which account you're using to submit the extrinsic. We'll use Alice, which is the unlocked seeded account. And then we go to system module, remark function. And here you can submit anything you want. For example, 0x323444555. 6. So this is a hash. It's just some data, just some bytes that I've decided to put into the chain. And if I submit this, sign and submit. Okay, now we have submitted this, but we don't know. Let's try and find it in a block. So we have this chain info here. So we don't know when this happened. So let's try and check out some blocks. 2, 2, 2 here. All right, let's see. And now we will see this extrinsic happen in one of these blocks that we opened. I'm not sure in which one it happened. So this doesn't have that extrinsic. 9733, not here either. There we go. There it is. Okay. So it happened in 9734. And you can see the extrinsic is logged here. And if we expand this, here that the remark was actually translated as 34 DUV, because that's how it's translated from the value that I entered. So this actually, when it's decoded into UTF-8, it ends up being 34 DUV. So this is how remarks work. And now we would have to go back when we were looking for some values. We would have to go back and look for all the extrinsics, for all the remarks in past blocks, right? So we know this one happened in 9734. Let's try and find it. I'll show you some code right now from the remark tools repository, which reads these extrinsics. So this is some very rudimentary code for fetching these remarks. First, we will import some types that we need. This is TypeScript, so we need some types. And then we will import some utility functions. Notably, I have an API bootstrapper, which creates an API instance for me that connects to my blockchain. And I also wrote a utility function to get the latest block. I can show you these right now here. So here we go. I import the API from Polkadot API. And then I have one function that creates the API for me. It's just a simple provider. And then I create, this is all from docs of the Polkadot.js API. And the getLatestBlock function uses the API RPC chain endpoint to get the header, and then it translates that header to a human readable number of the latest block of this chain. So why do we need this? Well, because I wrote a command which expects a from option, a to option, and a WebSocket option, along with a prefix option. So what do each of these do? The WebSocket option will tell the fetch remarks function to which WebSocket endpoint to connect to. It will default to my local network if not provided. So my local chain for testing. From will say from which block it should search. To will say until which block. If to is omitted, it will default to the latest, and that's why we need the get latest block. And from will default to 0. So if you omit from and to, it will just search the entire blockchain for remarks. Not recommended, very, very slow. This is why it's useful when processing this to have checkpoints. So you would process like 1 million blocks and then save that, and then process the next million and save that, and go through blocks that way. So you would have batches saved from before, and you don't have to reprocess them. And the prefix, the prefix is whatever we want our remark to start with. If you remember, in our specs repo, we had every single interaction start with the remark prefix. So if you go here, and if you look at some of the interaction, you can see each of them starts with remark : colon. So this is a good prefix to target so that we can ignore all other remarks on the chain. Because a lot of people are submitting a lot of remarks for different reasons, right? We only want our remarks processed. And so this entire function will just process these arguments, and then it will just go through these blocks, get every block's hash, then find a block for each of these hashes, then grab the extrinsics from each of these blocks, and if they are part of the system remark extrinsic, it will extract the argument and then check if they start with the prefix, and if so, it will push them to an array, which we finally get back in the console. Let's see that in action. So we know that our extrinsic happened in block 9734. I have my tools here, and now we'll just run yarn fetch. This is because I defined the command in remark tools repository. You'll find it in package.json as a defined command. We'll say from block 9000. We'll omit the to flag because we want it to go from 9000 to the latest block. And we'll just see what that gets us. So now it's fetching. It tells us it connected to my local node, which is WebSocket 127.0.0.199.4, which is the default port on which the node is running. And it's processing block range from 9000 to 9815, which is the current latest block. And you can see here that we got in block 9734, our remark 0x33344455556. So we got it. That's great. We can also search by prefix. So if I add in a prefix of, I don't know, 0x1234, then it is not going to actually find anything. Now, the reason this is taking so long is twofold. One, this is a non-compiled version, which goes through the TypeScript interpreter first and then executes the JavaScript in the code. Two, it's because it's processing a lot of blocks over and over again every time we run it. Ideally, we would just save all the remarks we found and then just process the next range. But this is just for demo purposes. So we got back an empty array, which means it didn't find any remarks with this prefix. All right, let's try our prefix that we know exists. So let's see 0x333. And let's speed it up a little bit, put it to 9700. There you go. So now it found the remark that we've been looking for. So we can define a prefix we want found. And this is actually going to work even in UTF-8 mode. So because we saw that our remark is translated as 34 DUV, we could potentially put 34 as a prefix, 34D, for example, and that should produce a working prefix. So let's see this, 34D. Let's see if this works. Because it's going to automatically translate it into hex. There we go, it found it. So prefix works both ways. You can put in, and this is just a demo of the code used to process these remarks from the chain, to get them out. Now, this code just gets them out. What you do with them is up to you. So I hope this inspired you how to hack custom things onto a substrate-based chain, because they all support these remarks, and this is very interesting. And Polkadot.js API is actually fairly straightforward to use in this way, because it has all of these direct interactions and connections to the chain that you can use to query it for data, either from the node directly or from the block or from the state or whatever. So go to the Polkadot.js API docs, look into that, hack through it, try and think of a scenario that you could use with remarks, and let me know what you come up with. I am open to any questions. If you have any in the chat or via email, just contact me, Bruno at web3.foundation. You can also find me on Twitter at Bitfalls, BITFALLS. And also, let me just put some ideas in your head about what to use this for. So since everybody sees the remarks, you can use it to create and this is what a developer from Parity, the development shop that builds the substrate framework, did a year ago, to develop a collective drawing. So everybody can submit some coordinates and a color into the remark, and then a script would read all of those remarks and draw those on a canvas to get a collective drawing application. Whatever you submit as a remark gets drawn on the pixel. And this is how you can basically get like a 1 million pixel website that people can color and paint and so on. Another implementation is a chat app. So you can basically use a prefix to define a chat room, and then everybody can emit remarks into that chat room and other people can see them. So all you need to do is build a script that will read the messages of a specific chat room and display them, and you have a chat room. You don't even need historical past blocks for that, because you can subscribe only to new blocks. So when somebody joins a room, they don't have to see the history of messages. They can just see the new messages since they came in, which is fairly interesting. So go out there, go wild, explore the network, abuse the network. It's what it's there for. Try to implement some of this crazy functionality, and I wish you luck. Let me know if you have any crazy ideas, if you need help with anything, or if anything is not clear. I'm always at your disposal, and I hope to see you in the Polkadot ecosystem. Thank you very much, and until next time.
Thank you, Bruno. It was a great recording, and the workshop actually was, pretty easy to use. I really liked from the workshop. I really liked at the ending where he literally had to show some the use cases, right? How the best ways you can actually apply the use cases you can build during this hackathon for on Polkadot. And these are applications that are pretty easy to build. And then of course it's always good to listen to the guidance of the mentors and the sponsors and what they say that makes sense and what you should build. The next panel, the last workshop, It's going to be on smart contracts. We have our friend joining us from Sydney. So is that morning in Sydney now? I think it's daytime in Sydney or morning. He should be joining in a minute. Okay, while we wait for him, I will just go ahead and again share my screen and then recap some of the things we talked about earlier today in terms of the hackathon and then the things that every participant should know. Um, Basically with the hackathon, with the Babylon projects, the Babylon projects, the goal with this hackathon is essentially bringing people together to build where we are, enabling the next generation or enabling entrepreneurs to actually have access, right? Or democratizing access to innovation, to investment, to mentorship, and so it's pretty great that we've been able to get close to 1,000 people. It's about 950 people now on the Discord channel who are participating in the hackathon from 65 different countries, where we have 30% female, right? As we are focusing on diversity and inclusion. The good part of this hackathon that excites me starts tomorrow, right? Where we're going to have the yoga session, and then we have great sponsors. And then also we have a lot of good news for tomorrow that will be announced, including our partnership with Hired, right? So with Hired.com to help people actually get jobs, especially people who are in our communities, right? Now that many people are losing jobs, so you can apply. We have a special link for Hired that we're going to share with you in the community tomorrow, so that you can actually use that to apply and then potentially maybe get jobs. And in publications too, we have lots of media publications that's going on. This is the community on Discord. Please make sure you get yourself used to this community, especially the team formation and the team registration. So you form a team in the team formation, and then you have the leader of your team go register on the team registration, right? And then you can find all the sponsors and the prizes and the challenges here in tech support, in challenges and prizes. You can find everything here. And essentially the goal here is for you to find what you want to build on, ask questions. All the presentations and workshops are already here. So you can easily just get to this place and watch or go through the DEXs again, and then or watch whatever you have to watch and be sure that you understand how to do this, right? Especially with the workshops. The workshops are actually very interesting. They're all very short, not too long, and then very easy. Actually, they describe the processes on how to build so easily that you should be able to build a few dApps by the end of the weekend. Engagement, you can also check the squads here. The teams are already being formed. So on the team squad, on each channel, we can have only more than 50, we can have only 50 channels in each category. So we have two categories right now. So that means we have around 75 teams formed so far. Please make sure you form a team or join a team. If you don't have any team, please ping me or ping any of the team members or any of the ambassadors so that we can help you with this process to make sure that you have a team during the hackathon. Again, the submission timeline, on Sunday, 11th October by midnight, you have to submit. Then we'll announce the finalists. We'll announce the finalists Thursday midnight. The finalists will be 20 teams. Now, these 20 teams will go ahead and present in the final award ceremony on Saturday, 9 a.m. next week. The submission requirements, you have to build an MVP that really works. Again, for you to win the main prize, you have to build a very good MVP, you have to have a good presentation, and then you have to build a project that potentially could really become a company, right? So essentially, since we have $100,000 from Aveslayer that is going into as an investment and then also acceleration to the winning team. So it's advised that you actually go ahead and build out platforms or tools that or companies or MVPs that could actually end up being big companies or unicorns. Essentially, that's what we're looking for. And then while submitting everything, please make sure to have an idea that's pretty creative and that is innovative and that works, right? And then you have technology behind it, and then you have, it's basically something that can be used by people. It should be great if you have real if you have a marketing strategy, right? However, even if you don't, we are here to help you, and then we're here to support you, to actually provide you with marketing support, and then many more of such things. That is essentially why we have the Babylon project, right? It's really about helping companies that could actually become successful, and then helping them become more successful globally and also locally. We have so many partners that we cannot mention all of them. We're happy and we're grateful to all our partners who have helped in this journey to bring the Babylon into realization. This happened within 3 months, and it's pretty exciting to see how we've been able to people have been able to come together. The community itself supports itself. That's the essence, right? Where members of the community are actually there replying to other people, helping each other, especially big thanks to our mentors and then our judges, who are mentors and judges, and all our speakers who are actually offering their knowledge, offering help, and then also they will also be able to offer other things, including their network on other things, especially if you're building something that is useful, especially if you're working hard. The goal with the Babylon projects, again, is really to show that, hey, if you have something that you're working on and it makes sense and it can change the world, there is an opportunity for you. There's chance, right? And so thank you, and then welcome again to Babylon. This is the end of today's talks. We'll continue tomorrow, and tomorrow will be a lot interesting with all the panels. However, I will always advise that you don't have to send all your team members to listen to all the talks. All the recordings will be provided in Discord channel, or all the panels also be provided in Discord channel, so that you can watch them later or you can watch them during the event. However, the most important thing here is that you end up building tools, you end up building your MVP, you end up hacking so that you can be considered for winning. Thank you, everybody, and have a great day, evening, morning, and night. Bye.